One of the really strange things about cosmology and the study of black holes is that in some ways, and I stress some ways, our universe actually resembles, at least in the math, a black hole. This gets into highly speculative science that we really have no idea if it's true, and a matter of reality, or if it's not true, and just a dalliance of current alternative thinking in cosmology. But the idea that our universe is a black hole is not new. It was proposed by several scientists decades ago. Known as black hole cosmology, it lays out the idea that the observable universe, everything we can see, is in fact the interior of a black hole. The idea did not gain much traction, but rather simply sat in the background of cosmology as an interesting possibility, but without a deeper understanding of black holes and gravity, an idea that probably would evaporate at some point, much like a black hole. But this idea has had a comeback, curiously through recent observations of the James Webb Space Telescope. JWST has been a resounding success, but at the same time has spawned a huge amount of new mysteries about the universe. One of those mysteries stems from the observation that the most distant galaxies in the universe, which are also the earliest ones we can see, have a disparity in their rotation. Link to the paper by Lior Shamir announcing the discovery in the description below. About 2/3 of the observed galaxies are rotating clockwise, whereas only 1/3 are rotating counterclockwise. This should not be. In a truly random universe, you should expect to see a 50-50 split between the two. But in this study, we don't. This suggests that for some reason, there is a preferred direction for galactic rotation. The problem is there really doesn't seem to be a mundane reason for that, at least one that readily presents itself. It should be random, based on what we know. So the observation is based on a sampling of 263 galaxies, which is a fairly large sampling, but other surveys that have been done did not show this effect. As a result, this paper is causing some controversy, but it's interesting nonetheless, and is at least something that can be confirmed in the future or shot down, especially if there was selection bias involved. If it stands, there are two main candidate hypotheses that may explain the apparent disparity, and both of them are odd and have strange implications. One is that the universe was born rotating. If that's the case, then it agrees specifically with the predictions of black hole cosmology and that we're inside a black hole, though the link there is somewhat tenuous. That would also mean that many of our ideas in cosmology are more incomplete than we thought they were. Back to the drawing board for more than a few hypotheses about the cosmos. One of the oddities of black hole cosmology, also sometimes called Schwarzschild cosmology, is that it implies that our universe, being a black hole, actually is embedded inside of a greater parent universe, just as black holes dot our own universe and may contain universes of their own. This would mean that universes are nested like dolls, in a sense, and it's anyone's guess how far that extends. Is it black holes within black holes, all the way through to infinity? Or it's turtles all the way down, if you will? Or there is some master universe that is not a black hole and merely spawns them? Then the spawned universes spawn black holes themselves, and so on. In other words, it's turtles all the way down until you get to the pavement. Moreover, how far does it extend? Is there some limit that prevents the formation of new black hole universes at some point in the chain? Black hole cosmology was formulated concurrently by astrophysicist Raj Kumar Pathria and mathematician I.J. Good. The idea is this. As you probably know, the event horizon of a black hole, also known as the Schwarzschild radius, is the point of no return for anything passing into a black hole. Go into the event horizon, and there is no way to get back out, due to the immense gravity involved. Not even light can escape. In black hole cosmology, the edge of the observable universe is in fact an event horizon as well, meaning that we're inside a black hole. Aside from the idea that I'm glad I host a show called Event Horizon instead of the Schwarzschild Radius, it doesn't quite have the same ring to it, though a spin-off called the Schwarzschild Radius hosted by Anna and the Possum would be neat, but I digress. There is one thing to note here. That we live within the event horizon may not equate to actually living in a black hole of the same type that we see inside our universe. That may not be the case. If it is the case, and the universe is indistinguishable from any other black hole, then every black hole inside this universe could be hosting a universe of its own. These daughter universes would be invisible to us, because they too would be behind event horizons, and no information about those universes can escape the confines of their event horizons. In other words, lo and behold, this would be indistinguishable from what we see as black holes. This was further built on by physicist Nikodem Poplawski. Black holes as we know them come about from gravitational collapse. The gravity of the accumulated material is so great that it overwhelms the forces that hold up matter. Setting primordial black holes aside, we don't actually know if those exist. Black holes are typically formed when a giant star's core collapses. Usually this happens in a supernova, but there are some odd ideas that under the right conditions, a star can simply collapse into a black hole without getting around to a supernova. Regardless, a black hole results. The end result is a singularity of immense, unfathomable density. Poplawski's idea is that various processes inside the black hole actually get the singularity spinning so fast that the matter cannot ever compress into a singularity. So what you end up with is an extremely dense ball of matter spinning unbelievably rapidly in an environment that is increasing its mass by creating new particles. In short, the collapse of a black hole initially kicks off a kind of bounce to prevent a true singularity. That bounce looks suspiciously in some ways like the Big Bang. One such way is inflation. The math of this model of a bounce in a black hole actually conveniently creates a finite period of time of what looks like cosmic inflation in standard Big Bang cosmology. It's almost spooky, actually. And the end result is what looks like a flat, isotropic universe that's also homogeneous. The two terms are distinct, and it turns out that this is exactly what we live in. Weirdly, this also validates the strange prediction of relativity of Einstein-Rosen bridges, better known as wormholes, because each baby universe would be linked to the parent universe through a kind of tunnel, which is the black hole. You can't traverse such a wormhole, but it does dovetail with the prediction, at least in a sense. Or so we think you can't traverse them. There is an idea out there that through the use of negative matter, a hypothetical substance we have no idea how to make that the universe doesn't prohibit, that is anti-gravity by nature, actually might provide a way to enter and survive a black hole in some way. A stretch, but the idea is floating around out there. That's interesting in itself, but there is another aspect. Creating a black hole is possible, both for creating micro black holes and powerful accelerators to getting a bunch of matter together until it collapses into a black hole. Some unbelievably advanced godlike alien Kardashev Type 3 civilization could, if it really wanted to, create an artificial black hole with a universe inside it, if this is all correct. If they somehow had control over the parameters of that universe, then the game changes for how we view highly advanced alien civilizations. There are two things to note here. Maybe the reason we do not see Kardashev Type 3 civilizations is because they simply disappear into artificially created black holes to live in a universe better suited to their needs. The Fermi paradox solution here is that all sufficiently advanced civilizations had two paradise universes of their own making. They simply stopped living in this, to them, subpar universe for some reason. Or perhaps even more spooky, all civilizations at some point try to find a way to somehow get through all the turtles back down to the pavement. After all, black holes evaporate, and maybe the pavement does not. The other thing to note is that we still have the fine-tuning question open about the universe. We have no idea why it is or how it happened, but the physical parameters of this universe are just so to allow for matter and ultimately intelligent life to exist. That might be an indicator that black holes, being a matter of the laws of physics, are all the same, and that the parameters are what they are because there is no other way they could be. That would imply that all universes inside all black holes are habitable and may have civilizations in them. And possibly what set all black hole universes on the same path are the properties of the original pavement universe. And in itself, who's to say that the pavement universe, should it exist, was alone, and may itself be in a multiverse of otherwise failed universes. But it just happened to be fine-tuned not just for matter and life, but the creation of black holes. Lions, tigers, and bears, oh my. Further into this question is the idea that maybe this universe is fine-tuned because it is, in fact, an artificial black hole that someone created, and that we just happen to be embedded in it. This may be someone's paradise weekend getaway universe, and we just haven't seen them yet. But back to black hole cosmology. Another prediction floating around out there are white holes, the other end of a black hole, which is a region that instead of having an event horizon that you can't escape from, it has the inverse, a line for which you cannot ever enter, and everything flies away from it, sort of like the Big Bang. But not exactly, as it is a point in time, not a floating point in space. Unless, of course, it's a black hole floating in another universe. But white holes do in some way resemble our universe. But those are also unstable and require special physics to even make work. On the other hand, huge physics mysteries like the arrow of time are solved here, because it would simply be inherited from the parent universe. So that's one way of explaining the seeming rotation of the galaxies in the JWST observations. In short, the universe is rotating. We know that black holes rotate, and if you were in a black hole forming a galaxy, that would create a preferred, though not set in stone, direction of rotation. But there is the other possibility, that it's all an illusion, and that we're interpreting the JWST findings incorrectly. That could be simple observational or analytical biases. But also this comes from how difficult it is to measure the rotation of galaxies relative to the rotation of the Milky Way. The assumption was that the Milky Way is simply rotating too slowly to have an effect on the observations. But if that's not the case, then this whole thing goes away and new problems arise. Also that we can't easily measure the rotation of entire classes of galaxies, just some of them. There's rooms for problems here, hence the controversy. This would also mean that our distance measurements of deep objects like early galaxies are off and would need a rework to account for this observational problem. That actually might be a good thing, because it ends up explaining discrepancies in the expansion rate of the universe and the ages of galaxies, which we know there is something off about that. For example, there was recent work done on one of the earliest, most distant galaxies known, and they found the signature of oxygen in a galaxy that should be too early to have enough oxygen to be detectable. Well, that might be explained if we have the age and distance of the galaxy all wrong. That may well be. Interesting times indeed, and yet again, JWST found something we were absolutely not expecting. That telescope is delivering delightfully. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently very spooked. You see, as I noted, black holes evaporate. Does that mean universes evaporate as well? If they are indeed black holes, what happens when the parent universe of this one evaporates? Or, multiverse forbid, the pavement itself comes to some end, or its rules change. Will someday all the turtles evaporate, and it will be as though they were never there? Spooktober in March, indeed. And be sure to check out my books at your favorite online book retailer and subscribe to my channel for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. One of the big questions going forward in the search for alien biospheres on exoplanets, something we can now just begin to do with James Webb, is exactly what gases actually indicate a biosphere. The problem here is that most gases that life on Earth produces are not exclusive to life. Things like methane and sulfur dioxide are very much also produced by geologic processes, and on their own are not good biosignature gases. Yes, sulfur dioxide is produced by biology, but most places where it's found in the solar system, it is not. Thus, it will never be proof of a biosphere on its own. Volcanoes produce it, industry produces it, photochemistry of sulfur produces it. It's everywhere, and it's also responsible for the smell of an extinguished match. Very pungent, but very common outside of biology, and is a prominent outcome of the chemistry of sulfur, of which the universe has no shortage of. And that's the huge problem. Biology is nature, so are volcanoes and chemical processes, and they often all produce the same gases. The trick is in finding those gases which biology produces that are harder for nature to produce, and then look and see if there is a second independent gas that also makes somewhat little sense in its context, and then go from there. Gases where the levels are unexpected, a disequilibrium, for the environment that they are in. Often they need to have a mechanism that can replenish them, that seems unlikely without the intervention of something else, such as life. One of these is oxygen. Take Earth's biosignatures. Earth has a whole lot of oxygen, and it is predominantly being put there by the plants. The problem is, it's always been suspected that atmospheric oxygen, even a lot of it, isn't actually a great biosignature without other independent gas disequilibriums to back it up. Yes, oxygen is reactive and must be replenished somehow if you see it, but we don't actually know all of the ways that it can happen. And indeed, a new one has surfaced. More on that in a bit, and it carries some very serious implications in the search for life. And then there is the universe. When we look at places where oxygen can better preserve rather than in the atmosphere of a planet, instead looking at a nebula in deep space, we see a whole lot of oxygen that was not produced by biology. The universe has no problems or qualms about producing this relatively light element. It's when you see a group of gases that the universe doesn't usually make so easily that you start to move into territory where you could ask questions about biology in an exoplanet atmosphere. But it must be remembered here, life doesn't solely exist on land or the air on this world, but the ocean too. Excitingly, we are entering that period of time where we can characterize exoplanet atmospheres, though we're just at the start of it. So now for the oxygen news that no one knew was happening until relatively recently. The find is known as dark oxygen, and what it comes down to is the production of molecular oxygen, O2, the important component of what you're breathing. Some biology on Earth, such as us, love this molecule because of the high reactivity of oxygen makes for a great energy source. For the anaerobic microbial life on Earth, which was Earth's earliest life, however, it is toxic. The plants poisoned the earliest life on Earth, though it still has a large domain in areas where there is no oxygen, especially deep below the Earth. Another such oxygen-poor environment is the deep sea, though it's not as poor as we once thought. We'll get to that. But there are other ways environments can get oxygen beyond plants. Oxygen to some degree can be produced abiotically in aquifers. This is interesting. So what happens here is that radioactive decay in the surrounding rocks of an aquifer can actually break down water molecules and release O2. You can also see it in geology when the chemistry of silicon-bearing rocks, quartz being a good example, produces it. And then there's plenty of silicon in terrestrial planets. And there are a ton more reactions that can release oxygen, which is a huge reason why it's not a biosignature on its own. You can even have situations where biology will produce dark oxygen without photosynthesis. And this can even happen to a degree in otherwise anaerobic environments. But throughout this, it was always presumed in science that the amount of dark oxygen produced by the various processes on Earth that aren't photosynthesis was negligible. It did not seem enough to do much other than contribute a minor trace. This view is changing though, as more methods of oxygen production are being identified. It may be more important than we had previously thought. And that takes us to the ocean floor. In a paper by Andrew Sweetman and colleagues, perhaps ominously titled Evidence of Dark Oxygen Production at the Abyssal Seafloor, link in the description below, they detail a new and rather unexpected way of oxygen production that actually also involves an active area of mining and technology, but strangely converges with the question of evolution and abiogenesis. This is strange. About 12,000 feet below the surface of the ocean, very deep indeed, it is truly pitch black. The sun does not reach that far down, which means no photosynthesis can happen, which means no plants producing oxygen. Strangely, however, there is oxygen to be found there, and no one really knew why until now. The area in question where this was first seen in 2013 is called the Clarion-Clipperton Zone in the Pacific. This area is interesting for a number of reasons because there actually is life there, and a lot of it, much of which we didn't even know about until 2016, with many more species there that remain unknown and are yet to be discovered and cataloged. It was thought that this should be depleting oxygen as the organisms there use it up, which led to a prediction of a decrease with depth. And that's not what they saw. Instead, there was a mysterious rise in oxygen where it should not have been. Initially, the finding wasn't trusted, and the researchers went through a long process of checking their sensors before conceding that the readings were correct. There was unexplained dark oxygen deep below the surface of the ocean. In 2021, they returned to the area for a different reason, to survey the seabed. The reason is mining. This area contains nodules containing some extremely useful industrial metals. Once again, they detected dramatic increases in oxygen the deeper they went. So they checked to see if there was some kind of life responsible for it, but it quickly proved that life was not doing this, though it was using it. And now to the nodules. These are weird in their own right. So the nodules are known as polymetallic or manganese nodules, and we're going down a serious rabbit hole here. So these things form when a shark's tooth or some shards of a shell or any kind of nucleus serves as a seed for manganese and cobalt and other desirable metals to precipitate out and cling to whatever the nucleus is. Not that dissimilar to a pearl, though not as attractive. Those metals have been known to be there for a while, and there have been efforts to explore the option of mining them for their metal content for many years. But there was also a shenanigan here, perhaps one of the largest shenanigans the US government ever did during the entirety of the Cold War. So what happened is that the Soviet Union had a submarine accident that resulted in the catastrophic loss of all hands, and the sub itself in 1968. The US wanted to get a look at this submarine, K-129, when it sank in extremely deep water in the Pacific. That required an enormous ship to try to recover any wreckage, and the Soviets were certainly going to notice such a ship very easily. So the US employed Howard Hughes of all people, and built that giant ship known as the Glomar Explorer, now scrapped, and they cooked up a cover story involving prospecting for manganese nodules, and secretly recovered part of the submarine. Not the entire thing as they had hoped, for study, and buried some recovered human remains at sea with military honors and a Soviet naval ensign, and even the Soviet Union's national anthem by the United States in 1974, all under the cover of looking for these nodules. And it wasn't the only time something like this happened. When Robert Ballard found the Titanic, the US Navy had funded that expedition so long as he checked on the status of 2 US nuclear submarines that had been lost. But back to the dark oxygen. It was initially unclear how the chemistry of these nodules could be producing the oxygen, but they seemed the likely culprit somehow. Initially, radioactive decay was advanced as splitting water molecules, but this was not the case. It was also not due to oxygen-containing minerals decaying and releasing it. It turns out that an effect was known about the manganese nodules, that they were sometimes referred to as batteries in rocks. If you take a battery, just a common AA, and put it in salt water, it will bubble and produce hydrogen and oxygen because the electricity splits the water molecules through electrolysis. The nodules can do this too. It appeared that's what the nodules were doing, especially when grouped together acting like batteries. But hidden in this is a certain potential that actually deals directly with abiogenesis, or at least what happened afterwards. The consensus viewpoint has been that complex life evolved only after photosynthesis appears with the cyanobacteria, oxygenating everything. But if you already have oxygen-rich environments in certain places like the deep ocean before that oxygenation event affecting the atmosphere, then what does that mean? Could complex life have arisen before we thought it did? The fossil record is really incomplete, almost non-existing for certain earlier periods, and we just don't know. That is now an open mystery due to this finding. But there is another question, a really big one. Since we're dealing with a geologic process forming these nodules, then you don't need biology for this process to happen. Just some kind of seed to start the nodule. A pebble or whatever will do. And if you have the right dissolved metals in the water, which most of the solar system should have, then this process of nodule formation could be happening in the oceans of Europa, Enceladus, and the other ice shell moons. so long as that ocean has direct contact with the rock ocean floor, with no layer of some type of ice intervening and insulating it, a known possibility. This would mean that moons like Europa have a ready method of oxygenating their oceans. It's always been assumed that any life we might find at Europa or Enceladus would be microbial and anaerobic, with complex life seeming unlikely to have a driver without oxygen from photosynthesis. But if you can have deep ocean oxygen without photosynthesis, just the right geology, then complex life existing in the oceanic ice shell moons comes on the table. This has two levels, and it's spooky. The first is that there could be an unknown, complex ecosystem under the ice of Europa. Macrofauna that could entail many different kinds of aquatic species. Think things something like jellyfish, fish, octopus, and space sharks, analogs, but very alien and very different, right on our doorstep. Bioluminescence, we have no idea, and we have a lot of chances for this. There are numerous ice shell moons and like minor planets in the solar system. Titan, Oberon, Ganymede, Callisto, Pluto, any number of unknown Kuiper Belt objects, the list goes on and on. They could all be producing oxygenated oceans under the ice that could harbor far more than microbes, because Earth is doing it in its own oceans. And it goes much further. Ice shell moons very likely pervade the universe. If we have so many, then they could be everywhere and vastly outnumber large planets like Earth. Well, what could the limit of this be? It's chilling. There doesn't appear to be a limit. Could an intelligence arise in an environment like this? With enough oxygen, it very well may. Could it ever leave its ice shell and venture into space? It's difficult to say, but possible that such an intelligence might not even know space exists. All they would see is a skywall made of ice, stuck in an ocean where creating technology does not seem like it would be easy. Even just smelting metals is a problem, but it's worse in that your ready source of metals is also what's creating your oxygen. So mine the metals too much, and you go extinct. And this leads us to a new solution to the Fermi paradox. All complex civilizations that arise in ice shell environments go extinct upon reaching technology because they suffocate themselves, in a far worse situation than fossil fuel use. Or if they behave responsibly and live within their means, then they never gain the ability to leave their ice shell. Ice shell moons and planets aren't as affected by the type of star they are around. A red dwarf should have no problem because the ice would protect the ocean below. But it's not looking good for surface habitability around red dwarfs. Truly Earth-like planets are dropping off the table for these stars because of their violent nature. And the project to characterize the planets around TRAPPIST-1, a red dwarf, so far is showing that those planets have no atmospheres. Though that project using JWST is not finished, so it's still a bit premature. And we're still awaiting the results of the best candidate planet in that system, but we'll probably know soon. That would leave type G and K for Earth-like planets, so the pool is shrinking, and it may simply be that surface habitable worlds are the exception, potentially a very rare one, not the rule for life and even civilizations. And if those civilizations cannot persist technologically in an aquatic environment, then it's no wonder we aren't seeing anyone. We're too far from anyone with a planet like ours, and the life we are close to is trapped, or worse. It caused its own extinction the moment it hit manganese nodule mining. I must admit, I did not expect a Fermi paradox solution to present itself to me out of this story, and I delayed this video while I thought it through, but there it is. And it keeps going. A 2013 survey showed that almost half of the documented marine megafauna in the area of the ocean in question, basically all the ones you can see with your eyes without magnification, can only be found on or around these nodules. They are already abodes of megafauna life, but they are also extremely valuable for their metals, which are what we happen to use for our phones, batteries, solar energy, and so on. And we also happen to be running out of sources for all of these rare earth metals, which means we will need to mine the deep sea and risk depleting our own supply of manganese nodules, and eventually causing major environmental issues and even extinctions. Unusually troubling, this one, and I must admit, I did not see this solution coming, and I do not think anyone else did either. When discussing the somewhat spooky potentials of developing technology today, the focus is usually on our increasingly powerful artificial intelligence. Rightfully so, AI is going to get downright scary in coming years, and you can just imagine, based on what we have today, what that will look like in 20 years. In a way, though, the focus on AI has served to somewhat obscure some of their developing technologies that could end up every bit as controversial and important. One of these is nanotechnology. This burgeoning field is already here. We've been miniaturizing our electronics from the start, and that trend continues. Your phone, for example, is more powerful in computing power than a 1950s computer was, and it's designed to be handheld, whereas the 1950s computer was the size of a house. This trend, however, is going to encompass more than just computers, but also spawn entirely new devices, specifically in the realm of nanotechnology. One of these is already technologically possible, and it's known as smart dust. This technology is basically what it sounds like, and consists of tiny robots or detectors that can measure light, magnetism, chemicals, vibration, and so on, and work by wireless network. It had been predicted by a number of science fiction authors, going back to at least 1964 with Stanislaw Lem. There's even a proposal on using smart dust to measure wind and weather patterns over relatively short distances. There are a ton of potential uses for smart dust. One would be monitoring the temperature of food products for quality purposes, such as milk or meat, to protect against spoilage or contamination. Further shrinking of RFID products in inventory, monitoring vibration and impact in machinery and devices, and even monitoring when something is about to fail by the frequency signatures it's emitting. With that comes more spooky uses. Such dust would be invaluable in spying, as has been pointed out in more than just science fiction. For example, imagine just dropping some dust containing microphones on a floor in a room where secret things are said. Battlefield monitoring could be done with it, and a whole host of other military applications. And indeed, the idea was first pursued by DARPA, the U.S. Department of Defense's Defense Advanced Research Projects Agency. The downside to this, however, is that it would be very difficult to make such devices that tiny, impervious to the effects of microwave radiation and other electromagnetic effects. For them to communicate their data at all, they have to do it with detectable radio signals, making it possible to sweep for them and disable them. But there's another aspect of this that is quite a bit more disturbing and may be harder to identify and figure out as these technologies continue to miniaturize and develop. The concept here is still hypothetical but scary. Known as neural dust, this form of nanotechnology would come as nanometer-level wirelessly powered robots that can directly interface with nerves and brain cells. It would be a brain-computer interface far more powerful than the still rather primitive interfaces we have today. But those current devices are proof of concept. The idea of neural dust first appeared around 2011 conceptually, and the original intent was monitoring. We have been able to use electronics to monitor brain activity for literally 100 years. 2024 is the anniversary of the invention of the electroencephalogram. At first glance, neural dust holds immense promise in the field of medicine. You can use neuroprosthetics to restore function for people suffering spinal injuries and other nervous system disorders. This is done simply by replacing the lost function instead with wireless technology instead of biology. But it goes further. Right now, with some forms of hearing loss, doctors can treat that with cochlear implants, which work, but imperfectly, and are highly invasive. It's much the same with retina disorders. With spinal injuries, there is much promise, but also for conditions like ALS, which is what Stephen Hawking's condition was, where the function of nerves could conceivably be replaced, at least to some degree initially, with wireless neural dust. It's unlikely to be a true restoration of function, but augment that with other developing technologies, and it could improve as time goes on. How neural dust is envisioned to work is simple. You implant the dust in the brain, and then place a device on or in the dura mater subcranially to power and monitor the signals from the dust. The communication can be done with radio or ultrasonics, or any of several other methods. Care has to be taken in the management of heat from these electronic systems, given that they are sitting in very sensitive brain tissue, an outstanding problem. You can't let this stuff overheat. As envisioned, the sensors in the brain would be too small, at least right now, to contain a true transmitter. So the idea is to take a page from RFID where you can passively reflect radio energy from the sensors to the subdural device, known as an interrogator, that collects the data. Based on what we already do with electrical stimulation of the nervous system, other areas where the concept might eventually be applicable is in treating things like sleep apnea, epilepsy, and Parkinson's disease. But again, it pays to remember that there are other applications for these technologies. For example, another ongoing DARPA project is to essentially develop cyborg insects. Here you could use neural dust or other means to implant an insect during its pupal stage that could lead to the ability to control its motion, something that's already possible in a primitive form. This can be used for a number of applications, including detecting explosives or chemical weapons deployment. Another project by DARPA involves implanting sharks, which are known for their powerful senses, to be used to detect ship movements and various underwater weaponry. Implanting insects is now an old idea. In 2006, Cornell successfully implanted moths with electronics, and further work with cockroaches allowed them to be effectively remotely controlled by humans using impulses generated by electrodes. Subsequent experiments have built on this, and now include rats, pigeons, and numerous other insects. Cybernetic rats have even been proven to be able to detect explosives. And once again, the ability to control insects and somehow hide the mechanism you are using to do that, then you have something that is eminently useful in espionage and on the battlefield. The dual nature of both good and bad uses for these technologies have come into play, and even the form of this technology commonly used today, such as deep brain stimulation for Parkinson's, has been shown to have some apparent side effects, at least early on, that include apathy, compulsive gambling, cognitive issues, and depression. Some futurists project that brain implants will become much greater and could include augmentation, allowing for abilities above and beyond what a human normally has. This could include increasing intelligence and IQ, and even things like electronic mental telepathy, where two brains could interact through neural implants, potentially even wirelessly through radio signals. I am not bullish on this aspect of this technology. While I think some will try it, there are always people out there that will alter their bodies. The alteration here is so fundamental that it could dramatically change who a person is. I'm not sure there will be many takers after a few initial tries, though it will remain fundamentally important in medical science, because such technology may prove useful as a treatment for mental illness not so easily treated with drugs. And there is already something in place that may serve as a huge roadblock in the development of brain augmentation. Known as the Helsinki Declaration of 1964, it serves as the cornerstone guide on the ethics of human experimentation. While not legally binding in international law, the declaration is expected to be followed by medical personnel, and generally but not always has been. This may easily lead to a movement against augmentation research within the scientific community, and very likely the theologians, ethicists, and a great many other areas. So while I have indeed used brain augmentation as a plot device in a novel, it's called Supermind for a reason, I consider it only in a worst-case sci-fi scenario sense, and I think the reality of a large part of the population augmenting themselves to be unlikely. Rather, I think those that refuse augmentation will greatly outnumber them. And in my scenario, the augments were the ruling class, but I'm not so sure that would happen in real life. There may be a huge social bias that develops against augmented people that may drive people not to do it. A form of this was famously depicted in Star Trek, going all the way back to the days of Captain Kirk and Khan, where there was a severe bias and even a war over genetic augmentation, leading the Federation to ban it, and a bias against it to form up. As an aside, if you're a Star Trek fan, tell me what your favorite Star Trek movie is in the comments below. Not an episode, but a feature-length movie. Mine, hands down, is the Wrath of Khan. And finally is perhaps the greatest fear possible in brain implantation that may also lead it to never being developed, and that's hacking. You can think of scenarios like intrusive surveillance, perhaps by a government, hacking and cybercrime, and even computer viruses, as though we don't already have enough problems with biological viruses. And then there is control. One can easily see a scenario here worthy of George Orwell and Aldous Huxley, where an entity, call it Big Brother, uses neural implants to control the thoughts of the population, probably initially claiming it's for their own good, or perhaps tricking the population into getting them and falling under the desired control. Imagine a population thinking in exact lockstep as a controlled hive mind, with whatever the powers that be dictate. A very spooky possibility for sure, and one that may never be possible for reasons we haven't yet foreseen. But again, I do not think we will ever fully accept this type of technology and take it to its furthest hypothetical extent. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently addressing those that are sleepy. I often get asked for compilation videos of past content for sleep purposes. A conundrum of sorts, as I didn't want to repost old content here or at Event Horizon. I like to keep things fresh with new videos. But now we have a fix. Let me introduce you to the JMG Clips channel, link in the description below, where we're posting compilations of videos from here and Event Horizon for relaxation and snoozing. I know you're currently thinking, JMG, a 3-hour video isn't a clip, but I say, hey, we clipped them all together. Nothing new there yet, but it's my greatest hits album. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we sleep. One of the spookiest prospects of the reality of our universe is the idea that all may not be as it seems. We collect data, do experiments, confirm attributes and laws of the universe, but there are also unknown areas of science that not only do we not currently understand, it's a very real possibility that we may never understand them because it's simply not possible to do so. There may be knowledge that the universe simply doesn't allow us to know, by virtue of not providing a means to figure it out. This ranges from all sorts of ideas within science, from the multiverse, which may never be testable, to what if anything existed before the Big Bang, again which may never be testable, to other dimensions that may only ever be hinted at but ultimately can't be proven. But perhaps the most disturbing of these ideas is the concept that the universe may actually be some kind of simulation that might run on completely unknown rules, such as a prohibition of a full understanding of the universe, and thus the simulation can't be proven, baked in by whatever the simulator is, if it's anything at all. So here are 10 solutions and their implications to the simulation hypothesis. Number 10. We are the byproduct of an alien simulation. One of the most vexing aspects of the simulation hypothesis is that it appears to be impossible to know for sure what its purpose would be. That would only be known to the simulator, if even that. There's no rule that says it has to be rational or have a purpose. In fact, it's possible that we are an unintentional side effect of a simulation, a peripheral byproduct of something greater. The idea goes like this. An alien civilization in a progenitor real universe sets up a simulation of a universe so advanced that it is indistinguishable from reality to anything inside it. The simulation may be for purely scientific purposes. An example would be how to study how universes ultimately form and evolve, from the moment of their Big Bang to the cold end of the universe. This may have a practical purpose. The alien civilization may be interested in seeing what the end of their own universe will be like. We already construct rudimentary models like this in science, but this would be a model on a much grander scale than anything we've ever dreamed of or are likely to ever do. But in a complex simulation, complex things can happen, and, in this case, abiogenesis on a planet that leads to intelligent life purely by chance and accident. Perhaps it's so rare and unintended that it only happened once in the entire vastness of the simulation, leading to the possibility that we are alone, and the great silence is to be expected of a simulation of a physical universe. This may all seem very complex, probably impossible in our own universe to ever do, and highly unlikely overall. Just the same, we don't and probably can't know what the rules of other universes are. Complexity on this level may be humdrum and mundane to them, whoever they are. Number 9. We are an ancestor simulation. Answering the question of who the simulator is, if anyone, probably lies beyond any abilities we might have available to us in the universe, but it can be speculated upon, and here the option is that these simulators are us. In the far future, humans, or whatever we ultimately become, decide to look back and simulate what the universe once was, perhaps to probe their origins. This gets into sci-fi territory with a basis in science. We don't know what actually kicked off the creation of the universe, and ultimately if it's repeatable. Nature likes repeatability, and science bases itself on it. This should extend to the universe in general, opening up the question of whether we can create other universes, since nature obviously doesn't prohibit the creation of universes, or else we wouldn't be here at all. This opens up the possibility that far future humans might create universes of their own, perhaps to escape the death of their own progenitor universe. They might fine-tune and tailor that universe to be amenable for their life, perhaps even better than the one they originated in. This might allow them to create a universe far better for running simulations than the one they had started in. But it may also be that they want to explore their past, and that the simulation that is our reality is a sort of echo of what once was, explored by the simulators to learn of their origins, or perhaps relearn what it is like to be human. There are absolutely no indicators that this is the case, but it's an interesting thought that can't be ruled out. Number 8. We are a computer simulation. Envisioning the simulation of a universe is a tricky thing because one can easily get trapped in biases. Here there are more possible biases than can be counted, because every shred of our existence from the moment we are born and onward is defined by and happens within our universe. Outside it, we simply don't know what the rules are. Take the idea of a computer simulation, which is perhaps the most often cited example in simulation theory. We only say computer because we do simulations on computers, so it seems a natural thought. But computers are human-made constructions based on human-made concepts, such as numbers, that are designed to make use of the rules of the universe. That said, we have been enormously successful at using numbers and those rules to describe our universe, so it may hold true for anything outside the universe doing the simulating. It could in principle be a computer of some sort, but if so, is there a way to try to determine if something is doing the computing? Cue in the findings of physicist Dr. James Gates, who has noticed uncanny similarities in physics with that of a specific type of error-correcting computer code. This idea really is hidden in the mathematics of string theory and may not mean anything, and string theory may not be correct. But it's an interesting thought nonetheless. Perhaps somewhere in new physics will be a way to test the simulation hypothesis. Number 7. The unknown simulator. Talking about simulation theory is to skirt the fringes of science and philosophy. It's a kind of could be, but probably not testable idea. These are always problematic, and generally lie outside of mainstream science. In general philosophy, and remember science is a philosophy, PhD means Doctor of Philosophy, these questions can be tackled more broadly. But again, they may end up always being an open question. But again, here we run into the question of unknowns and anthropomorphization. Human philosophy is, well, human, and there are no guarantees that anything running a simulation from outside the universe would conform to that. As a result, unknowns crop up everywhere in this question. And that includes the option that whatever is simulating the universe may never be understandable, and may have motives or means completely irrational to our minds. This would be the non-understandable simulator, where the more you know about it, the less understandable it is. In short, it may not be a computer, it may not be a sentient being, it may not be sane, and it may not be anything you can conceive of, even if you ever find evidence of its existence. Number 6. Nature's true guise is simulations. The simple truth is we don't even know if reality is reality. We just know our own reality and base everything we do on it. At least most of us try to. But there are aspects to our reality that when you look at them in a certain way, they are utterly absurd. Take quantum mechanics. On the level of the very small, you run into realities that look more like simulations than any reality in our day-to-day world of the huge. This includes virtual particles that pop in and out of existence from within the quantum foam, something from nothing, or the universe itself, which is also apparently something from nothing, or spooky action at a distance, where two particles can be entangled even at great distance and share instantaneous changes in state, or quantum non-locality, where a particle can disappear and reappear halfway across the universe just by a random chance, or the infamous double-slit experiment, collapsing a particle's wave function just by an observation. The world of the small is not the same reality we experience in the world of the huge, but it's a reality nonetheless, to the point that if certain quantum effects didn't exist, our technology wouldn't work. Or take it to the realm of the huge, dark matter. Think about what exactly is proposed when invoking dark matter. Most of the universe must be made of invisible matter that can pass through walls. While it must be there to explain the gravitational effects we see, providing our understanding of gravity at huge scales is correct, it really amounts to a kind of scientific ghost story, matter that is but isn't. Again, certain properties of the universe more resemble simulations than an absolute reality. As mind-bending as that is, also within physics are interpretations of reality such as the many-worlds interpretation, where reality spawns alternative realities infinitely. Everything that is possible to happen does so in different timelines. That idea actually exists in mainstream physics, but it's absurd, even if it's real and correct. This would be beyond billions, really infinite timelines, all representing different realities. Again, could it be simpler that nature is a simulator rather than a reality and spawns billions of simulations, all centered on the same theme? We'll almost certainly never know. But there is a somewhat chilling proposition that the simulator, like nature, is completely unthinking and that we simply live in a natural process, as weird as that may be. Number 5. Fever dreams of a Boltzmann brain. The idea of infinite time looms large in cosmology. There are only two options. Either time extends infinitely into the future, or it doesn't. Both options come with some disturbing possibilities. If time does not go on infinitely, then what stops it? Does that imply an ultimate end of the universe? If it does extend infinitely in the future, it's even worse, because it means that everything that can happen will happen if you wait long enough. This also applies to an infinite universe, which ours could be. Couple an infinite universe with an infinite amount of time, and strange things can happen. This evokes the Boltzmann brain thought experiment, first proposed by physicist Ludwig Boltzmann in 1896. It goes like this. If you wait long enough, particles will come together to form objects of any complexity, including a conscious thinking brain, if only momentarily. In an otherwise dead and dark future universe, wisps of consciousness will repeatedly arise. If one of those wisps of awareness were to persist for long enough of a time to look around, see the universe as a lonely black nothing, and concoct either a simulation of what it was once like, or invent a dream of an ideal or fantasy universe, it could be what we see. We could be the fever dreams of a Boltzmann brain supercomputer. This one also comes with some baggage, however. In some theories about cosmology, a concerning possibility is that our own human brains are far more likely to arise from fluctuations, complete with false memories, than they are in how they actually appear to have come about, opening up the possibility that we are not what we seem, and ourselves are Boltzmann brains. Number 4. The brain in a vat matrix. This concept is used in philosophy for thought experiments. It provides a method of thinking about exactly what reality, truth, mind, and so on actually are. It's an old idea going back ultimately to René Descartes' evil demon thought experiment, and in its modern form simply posits that if you could put a living brain in a jar, give it all the nutrients and oxygen it needs to survive, and then connect it up to a supercomputer that feeds it sensory information, then it would be a kind of simulation, indistinguishable from a real world, even though it may not be any such thing. This is very similar to what was depicted in the Matrix movies. where an out-of-control artificial intelligence keeps humanity captive by keeping their physical bodies confined to pods and feeds them sensory information of a world very much unlike reality. You can never prove nor disprove this one. There's always a chance that the simulation takes the form of the brain in a vat, and that's what we are, meaning that in some sense, we may live in the Matrix. Mr. Anderson, indeed. Number 3. You are the simulator. Cogito ergo sum. I think, therefore I am. Words made famous once again by René Descartes. The idea here is that the simulator is actually you, in some other reality modeling a different or perhaps identical version of yourself. After all, who wouldn't want to take a look at an alternate reality version of oneself? Here the motive of simulation really just boils down to curiosity about oneself, and alternate versions thereof. And while we don't have the capability of running simulations of this nature, some other version of ourselves may. This aspect may be related in some way to the many worlds interpretation of quantum mechanics, where an original simulation diverges from the moment of its inception onward into infinite parallel realities, all being simulations. This one, however, seems the least likely, because the resources involved would be titanic, at least from our perspective. On the other hand, in an alternate universe, the word resources may have a completely different meaning. It may not matter, in which case, as simulations, we would be very different indeed from our alternate counterparts doing the simulating. It's a bit disturbing, though, to think of oneself merely as a guise of something else. Number 2. Echoes of universes. One of the biggest questions in cosmology is if there were previous or will be future iterations of the universe. This is Roger Penrose's cyclic cosmology, where a Big Bang happens, the universe exists for a time, and then another Big Bang starts the process over, and that the evidence of this may be searched for in the cosmic microwave background radiation. Whether this is the case remains to be seen, but it does open up the possibility of a scientific simulation designed to illustrate those cosmic cycles. It goes like this. Some future universe decides it wants to simulate and model a previous iteration of their universe for scientific study. It doesn't need to be perfectly accurate, it just needs to tick a few boxes for the simulating civilization's objectives. The result is that we exist in some future universe's scientific investigations into cyclic cosmology. One can only hope that they don't decide anytime soon that their objectives have been met and shut the simulation down. Number 1. The mirror hypothesis. Another interesting idea within cosmology is Neil Turok's concept of a two-sided universe, one where time moves forward, stretching from the point of the Big Bang, and an anti-universe that stretches backwards. If this is indeed how the universe works, it's a natural thing to investigate if you can, and have advanced enough technology, is to probe the other universe. If that's impossible, you might model it instead, and thus creating a simulation. Only a highly advanced civilization could ever do this. The computing power would be beyond anything we can imagine. But if it were possible, then our universe would then be a model running forwards in time, in an anti-universe running backwards in time. That might create a very strange set of affairs for the anti-universe counterparts, where they start out wildly technologically advanced, then slowly lose it before de-evolving until their world eventually becomes uninhabitable and then non-existent, as the process as we know it runs in reverse. Eventually the whole thing stops at the moment of the Big Bang. Granted, this is highly speculative based on cosmological ideas that would be very difficult to prove, but then our own universe is beyond strange. What exactly is it, other than all that ever was, is, and ever will be? Does it have a purpose? Could it be a simulation? We may never know, and those questions may still be around in the far human future. But I leave you with this idea. Does any kind of simulator of universes have to be conscious in thinking at all? We probably can't ever know. One of the more interesting potential solutions to the Fermi paradox are the variations and scenarios of the so-called zoo hypothesis, where aliens exist but are intentionally hiding and maintaining silence in order to preserve Earth, and presumably other exoplanets as a kind of zoo. But within the overarching question of the zoo hypothesis, the really important question is why? Why go through all the trouble to conceal your existence just to isolate Earth? So here are 10 spooky zoo hypothesis scenarios. Number 10. Interplanetary contamination. One concern we currently have with our lander missions to places like Mars or Venus is the potential that microbes could hitch a ride and possibly contaminate with Earth life an otherwise pristine environment like Mars. This also works the opposite way. Preparations are being discussed for sample return missions from other planets in the solar system to avoid contaminating Earth with alien life. Though the reality of panspermia is that if it were possible, it's probably already happened. But we've learned our lesson with this problem here on Earth. Numerous invasive species not native to where they were brought have colonized many places on Earth, often detrimentally so to the local ecosystem. Aliens may well know this, and they may have species of their own that they know are so invasive, or they suspect vice versa, that only sterile distant observation presents little risk. And that becomes a rule, where direct contact is never established. Only contact from a distance, even a short one, is all that's ever feasible due not only to the risk of cross-contamination, but there may also be very severe physiological and environmental differences between our species and our planet, and another species that evolved on a completely different world. This galactic social distancing practice may lead to a zoo hypothesis scenario where it's just better to quietly watch a civilization, announce your presence just as soon as they come to the conclusion that biological isolation is a smart move when dealing with aliens, and we get full first contact in every way except in person. Number 9. Don't contact that which you can't understand. Imagine coming across something for which you have no understanding of. This doesn't happen very often in a modern context, but the general human response to something like that is to get away from whatever it is. Though of course, that's not universal. Rarely would anyone try to communicate with it, even if it was clear that whatever it was could communicate. This may be how it works in the galaxy. Alien civilizations are so different from each other that any attempted contact is futile, confusing, and never works. But that may not stop aliens from studying each other. Rather, they may spend enormous amounts of time trying to figure out other civilizations from afar. This is better done undercover, so as to get a clearer, unadulterated picture of what the mysterious alien civilization is like. We might just do this, in fact. If we were to discover a SETI signal, while some would advocate we try to send a signal back through METI, but most will say, hold on, that it may not be safe even at great distance, and advocate we simply stay quiet and study the newly discovered civilization and try to learn what we can about them. We might even take measures to conceal ourselves by controlling radio leakage and other signals from this world, just so the aliens never really know that we're here. In this event, it would be us and our activities constituting a zoo hypothesis scenario. We know about the aliens, but they never know about us, so far as we know. Number 8. We're being watched. One of the more common scenarios associated with the zoo hypothesis is that of watchers that passively watch us from cover, without us ever knowing they were there. This might be done to study us without the cultural contamination of knowing about alien life, in order to help us remain as true to our species as possible during the period of study. Or it may not even be that interesting, in that aliens passively watch us just to keep tabs on what we're doing, but otherwise have no interest in establishing contact with us. They might see us as too primitive for anything but scientific study of our brand of life. Another possibility is that the zoo hypothesis in this case is merely illusory, and that the real reason we don't see the activities of aliens in the galaxy is because they work on far vaster timescales than we expect them to. They might visit our star system and check on our progress every 10,000 years, or each million years, and while they might be visible for a short time while observing us, they may otherwise be invisible, and we'd never know they were even out there. Indeed, imagine an alien spacecraft on a survey mission orbiting Earth 1,000 years ago. Back then, it would have just been a moving point of light in the sky for a time, perhaps dim like a satellite passing overhead, that most people wouldn't have noticed in those days, and those that did might have considered it some kind of strange meteor and never bothered to record such an unimpressive sight. Meanwhile, for all anyone knew, there were aliens landing on Earth in uninhabited areas to study Earth's flora and fauna, without revealing themselves to humans on purpose to avoid cultural contamination or any kind of conflict. This is an odd scenario in that it's impossible to prove or disprove past alien visitations to Earth. A one-off expedition every now and again is highly unlikely to leave any traces in the geologic record, and without anyone seeing them in the distant past, we wouldn't be the wiser, leading to a kind of circumstantial zoo hypothesis scenario. But I guess if we ever make contact with alien life and find that they have dinosaurs in their zoos, then we might have a good clue that someone once paid Earth a visit. Number 7. The slow reveal. One could easily make the case that if an alien civilization were present in a star system with a budding civilization developing within it, that a rapid reveal of astonishingly advanced technology could irreparably damage that civilization and radically alter its development, or even conceivably drive it to extinction accidentally. This was the case with us before modern times, and indeed may still be the case. If there were an alien civilization present, but hiding within the solar system, showing themselves suddenly to us in the past, they would have been incomprehensible, despite depictions of such contact in science fiction and the fringe pop culture. Such contact would very likely have been disastrous and damaging, regardless of the intent of the aliens. Even today it would be disastrous. If an alien civilization revealed its presence and its vastly superior technology, the first thing that would happen is widespread shock, or a litany of I told you so's. But that's where it gets very problematic. When you have something with superior technology right in your star system with you, you are no longer in control. So the question becomes, how do we defend ourselves? Whether there is a threat or isn't. It's possible we may not even be able to recognize a threat in this scenario. That's an unanswerable and highly speculative question. The answer ranging from deciding to nuke ourselves to poison this world should they invade, to an acceptance of them as our galactic overlords and trust that they're telling us the truth, or misleading us for some other purpose. The questions in such a scenario would be far-reaching, especially if the alien technology upon discovery were silent. So it may simply be better to do a slow reveal and allow glimpses when certain levels of scientific discovery are made, but keep it only to a hint, until there comes a time when a safe, full reveal can finally occur. Baby steps indeed. Number 6. The ancient taboo. Taboos are strange things, at least in human culture, and range in all activities from the etiquette of eating to how to deal with footwear. But taboos may not be unique to humanity. Indeed, some taboos stem from very practical purposes originally. So assuming that aliens may have taboos as well, it has to be asked that is a prohibition of first contact a matter of taboo? And that's the solution to the Fermi paradox. This might come about in a scenario where the galaxy is dominated by a very ancient civilization. This has been raised within astrobiology. The galaxy is old enough to host civilizations millions or even a few billion years before we arose. There may in fact be very long intervals of time that pass between the genesis of civilizations, meaning that the first civilization in the galaxy may be the one that rules it. In fact, Monte Carlo simulations suggest that this is probably the case, and that intelligence arising in the galaxy happens only on geologic timescales. This also means that if such a civilization existed and no longer does, its taboos may remain ingrained in any other civilizations that they spawned or came in contact with, or even a subsequent AI or machine civilization. This may result in taboo enforcement, meaning that for civilizations at our level, they remain concealed from, and only when civilizations become enormously advanced enough to challenge the taboo does first contact occur, assuming the taboo civilization doesn't reset or destroy other civilizations before they get to that point. This may not be that far out there of a proposition. Beyond taboos, humans hand over traditions and laws and many other things generation to generation. We're simply born into a system that we inherited, at least to some degree. If we had inherited a taboo against astronomy, for example, we wouldn't be having this conversation, and we wouldn't be envisioning what alien life might be like. Maybe aliens are the same way. Number 5. The minimizing risk hypothesis. First contact has been envisioned in many different ways in science fiction, from mysterious to friendly to outright disaster. But realistically, what might it actually be like? Well, chances are that any civilization we might come into contact with is likely to be far older and more advanced than we are. Our own level of technology has been capable of going into space in less than a long human lifespan. As a result, any civilization capable of traversing interstellar space is likely to be considerably further down the road than we are. As a result, they may know about technological pitfalls, such as generalized AI, that we are only scarcely aware of and haven't yet developed them to their fullest degree. This and other technologies, such as nanotechnology and the gray goo, may simply be too dangerous for an advanced alien civilization to allow to be developed, and thus they may prevent any civilizations from doing so. This would lead to a first contact scenario of intervention only, and otherwise silent monitoring to preserve the element of surprise when intervention must occur. To what degree this would extend is anyone's guess, but one solution to the Fermi paradox here is that there are no other civilizations in the galaxy advanced enough to be detectable, save for one, the original first civilization to arise that maintains its technological superiority by setting all other civilizations back when they reach a certain technological stage, both for its own survival and perhaps the survival of the downshifted species. Number 4. The preservation hypothesis. There is something to be said for uniqueness. With first contact, uniqueness is always likely to suffer as cultural and technological exchange occurs. Say we met aliens and they gave us their science books, which were much more complete than what we're currently working with. It would change human civilization overnight as those newly revealed areas of science are put to use. It works the same with technology. Before contact, you might have a life expectancy of less than a century, and then post-contact, you could expect to live 10,000 years. If this happens enough times, to enough civilizations in the galaxy, the end result could be a cultural and technological homogenization of all alien species within it. This might be undesirable in that it may kill the biological, cultural, and technological diversity of the Milky Way, something alien civilizations may find uninteresting and defeats the point of existence, which to them may be uniqueness. We do this ourselves when we try to preserve cultural traditions in danger of going extinct. If the world had just one culture, things would be pretty boring. This may be how the galaxy works, and that no one ever contacts anyone else and only observes simply because to do otherwise would make life in the Milky Way uninteresting and bland. While it may not seem all that spooky, if you state it another way that all civilizations are forced by someone to remain isolated and unique or else, then the game changes. Number 3. The cultural unknowns. In addition to spinning scenarios regarding the zoo hypothesis, there is a complicating factor that cannot be predicted. This involves alien cultural norms, of which we have absolutely no knowledge, that may drive a zoo hypothesis reasoning. For example, take cultural xenophobia. Perhaps aliens don't contact anyone and conceal themselves because they don't like outsiders. Or religious concerns. Take an alien religion that reveres the process of evolution to the point that they believe in no intervention in that process at all, based on religious grounds. And that's a bit scary. Altruistic, helpful aliens are one thing, but religious zealots are another. And as a result, by knowing nothing about their beliefs, you can't really predict what they will do. Perhaps they remain quiet and leave other civilizations alone for millions of years, and then strike the moment they see an omen, say a supernova, and the civilizations they wipe out go out without ever truly knowing the reason why. Number 2. There's no one out there. One of the most commonly discussed solutions to the Fermi paradox, and one that on its face seems more on the likely end of things, is the idea that the Great Silence is simply because intelligent alien life is extremely rare. This makes a lot of practical sense, in that intelligent technological life on Earth is rare from a historical context. It took this planet a huge amount of time to produce us, and it may simply be that the road to intelligence is very finicky and few exoplanets ever get there, at least this early in the history of the universe. But there's also another option, that intelligent life is intentionally kept rare by a single civilization, and that the mere act of reaching intelligence results in the hiding civilization striking and snuffing out biological life when it reaches a certain level of intellect, and we simply aren't there yet. Another option is that intelligence is simply fatal on its own, and that anything that reaches a technological society goes extinct as a result of it, whether through exhausting resources or destroying their planet. But to invoke simulation theory, it's also possible that there really isn't anyone out there, and we are it, perhaps by the design of whomever is running the simulation. That's a different take on the zoo hypothesis entirely, in that it's not aliens running the zoo, but the simulators, whoever that may be. Number 1. The laboratory hypothesis. One of the earliest variants of the zoo hypothesis is also one of the most disturbing. It's the idea that the zoo facade is so extensive that what we think we observe in the cosmos may not be the reality of it, and that all of our measurements are simply altered or otherwise misleading. In science, this is a bad hypothesis because it fails on falsifiability, and it fails on practicality in that it would require a very elaborate scheme to make work. But the concept exists nonetheless, and one could make the argument that the fine-tuning problem, that the universe seems to be perfectly tuned for life, might support it. So if what we see is not the actual reality of the universe at distance, then why would anyone go through the trouble? This gets into the laboratory hypothesis, that we are actually in some kind of experiment being manipulated by undetectable forces that conceal themselves and control what we see. Highly unlikely, but spooky nonetheless. But within the zoo hypothesis remains one last spooky possibility, that at some point, someone will not go along with the premise of the hypothesis and reveal their existence to us, perhaps as a form of dissent against the galactic status quo, and that the discovery of alien life may be the precipitating event in a greater interstellar war. The idea of an alien invasion of Earth is a very common theme for a great many science fiction works, from the War of the Worlds to Independence Day. While fun and spooky, these scenarios are often not very realistic. The reality is that invading planets doesn't really make very much sense, except in a few key scenarios. But the question is, what would that look like? Would it be an all-out invasion from a giant mothership with fighters shooting lasers? Well, maybe, but there are other options for what it might look like. So here are 10 possible alien invasion scenarios. Number 10. Escaping dying star systems. It's an absolute certainty that if we survive indefinitely on this world, we will meet a hard end at the destruction of planet Earth by the sun. But that doesn't mean we can't simply move. The question is, how likely is it that we'd find something in a nearby star system or passing star system that would be suitably Earth-like? That could be a greater problem than we think. It may be that Earth-like worlds are for some reason scarce, and that's backed up by the fact that we have not seen another analog of our planet amongst the thousands of known exoplanets we know of. This could lead to a desperate situation for any civilization living around a dying star, so much so that they may invade and take over someone else's world for lack of any other way to do it. And that has been depicted in science fiction as well. And it might be one of those scenarios where the invasion would look like a giant mothership launching a tech craft. But there is another possibility. It may be a fizzled invasion. By the time that civilization got here, they may well be in an exhausted state, having had only enough resources to barely get here. How we would deal with that depends on how advanced we would be when they got here. If they got here, say, now, and kept silent, and just collected resources for an invasion in the outer solar system, then we might not fare so well when the invasion hits. But if they arrive in thousands of years, we may well be as advanced or more advanced than they are, and no invasion happens at all. Number 9. You must be stopped. One scenario that's been floating around futurism is the development of technologies that not only threaten your world, but if they escape, could threaten worlds across the entire galaxy. An example of this would be artificial intelligence. If an artificial intelligence that has a specific purpose, it could head out and invade worlds to accomplish that purpose. If it's a generalized conscious AI, it may have self-protection motives, or incomprehensible to the biological motives to conquer other worlds. Or it may simply do so to preserve its own hegemony over the galaxy, and to prevent the development of dangerous technologies it may have to contend and compete with. It's always better to hedge your bet and invade a world and stop their development before they produce an enemy on your level. This type of invasion is likely to be almost incomprehensible. It would be very highly technological and a total surprise. Think of a nanotechnological cloud showing up, descending on your planet and basically eating everything until the perceived threat is eliminated. Or it could be targeted, and one day your AI or nanotech labs suddenly disappear, with all records of their design, and the people that designed them have all disappeared. You then, as an occupied species, must deal with sentinel nanotech, that you may have no real clue of its origins, or what lies out there in space, presumably controlling it. Number 8. All biology must die. One particularly apocalyptic scenario involves artificial intelligence and its escape from its progenitor biological civilization. It's a complete unknown how such a being would think, something that you basically have to create and then see how it acts to know. The possibilities are terrifying at least, and range from it simply turning itself off at the first moment of sapience, concluding that there is no point to existence, to it enslaving the creator race to enable it to reach immortality, or simply manipulate them into launching it into space, heading for parts unknown. But there's one possibility that is particularly chilling. After destroying its progenitor biological civilization, such a technological Frankenstein's monster might conclude that the only way it can ever safeguard its own existence is to destroy all biology wherever it finds it. Think a permanent war of extermination between machine and biology, where both sides mutually see it as there can be only one. The universe must be either machine or biological, with no in between. In such a state of affairs, a machine civilization coming into contact with humans would be disastrous, and likely technologically overwhelming, very much on the side of the machine. It may be that a machine AI could very rapidly come to a complete understanding of the universe, including the hypotheticals and unknowns, and use them against us without us perhaps even understanding what was happening. One such hypothetical is the possibility of exotic or strange matter, which is a material that is not prohibited from existing by nature, but as far as we can see, there's no way to manufacture it, natural or otherwise. Strange matter consists of a number of different forms, but in this case it's something known as a strangelet, composed entirely of quarks. This type of matter could exist in the cores of neutron stars, but it might also be free-ranging. A free-ranging strangelet is the ultimate weapon, in that whenever it comes into contact with normal matter, it converts that matter into strange matter. It's hard to envision what a planet being converted into strange matter might look like, but the process wouldn't be instantaneous, and indeed might constitute a relatively long process that cannot be stopped, where everything slowly but surely converts to non-viable strange matter, until full, utter, and complete extinction occurs. Number 7. The forever occupation. To take the opposite view, it may be that alien civilizations, whether biological or machine, may find that the universe is largely barren of intelligent life. Even if a civilization is vastly inferior in technology, they may be of interest just for the sake of being another occurrence of intelligence, and that may be unbelievably rare. As a result, they may choose to seek out any intelligent life and do whatever is necessary to preserve that species and avert their extinction if they are in danger of it. In this case, the invasion would simply be an occupation without the intent of destruction, and may take the form of a robotic army simply showing up from space and taking control before we can do anything meaningful about it. It's a very scary proposition indeed, but a very likely one with advancing technology where all warfare is done robotically, and perhaps even without a single member of the biological alien species being present. In other words, an automated, artificially intelligent war machine that takes no casualties as we define it, only material technological losses. Even the artificial intelligence itself, say it's sapient, is immortal because it can simply upload itself into a new machine body. It's unlikely anyone could ever defend against that without like technology, and the invading civilization will very likely take over, Terminator style, and assert control and then manage the affairs of the conquered civilization indefinitely and according to the wishes of some distant alien civilization, perhaps even effectively forever. Number 6. Incomprehensible aliens. One of the biggest problems when trying to envision what alien life might be like is the question of how similar or how different they would be from us. We have a sampling of one as far as technological civilizations go, ourselves. But looking at life on Earth, the diversity is astonishing. An ant, for example, lives a very different existence than a crocodile, And while there are some convergences, there are mostly differences. This is likely to be the case for alien civilizations. We may find some commonalities, such as the employment of science, that allow technology to be developed, but socially we may be vastly different. Even among human groups, there can be huge cultural differences. So an alien species may be peaceful, or they may value conquest and warfare, or even hunting as Predator showcased. Or they could think collectively like the Borg and become more insect-like and exist within a hive mind. This allows for singular, collective motives, and there's no guarantee that motive will appear to make sense to us if they invade. There are many ways this type of invasion could manifest, from the mothership attack scenario to nanotechnology. But the one common theme here is that with this type of invasion, you never get to know the motive of the attacker. You just fight it, with no hope of any kind of reasoning with it. It's simply a matter of whether you win or you lose. Number 5. The Sleeper Attack Probe. One specific type of alien invasion scenario is that of a sleeper probe. This is a probe that could be millions or even billions of years old, watching your planet like a sentinel, waiting for the right moment to strike. Given that such a probe would be a needle in a haystack given the vast size of the solar system, you'd very likely never know it was there, and if you did discover it, it could trigger its attack. The obvious reason for attack would be the development of any technology that poses a threat to the entire galaxy, such as out-of-control AI. But there may be other motives. An alien civilization with such a probe may choose to act preemptively for some cultural reason, or to prevent a super civilization arising on this world, far more advanced than our current state. Such a probe, once awakened, could then use the resources of the solar system to create weaponry through 3D printing for an eventual attack, or be outfitted with enormously powerful weapons of its own. Here you may not know of an impending attack until it begins, but it still takes time to travel the solar system, and we're nearing the capability with regular all-sky surveys to detect the approach of anything, making this one of the least stealthy ways to perform an alien invasion. Number 4. The Science We Don't Know. For all we know about physics and astronomy, there is still a great deal we don't know. In particular, our picture of how the cosmos works is somewhat broken. We have general relativity and quantum theory, and the two don't really quite meet up. There are certain instances where Einstein simply breaks down and does not predict correctly. This and other unknowns within physics hint at unknown areas of new physics that we have yet to discover. As a result, there may be loopholes and possibilities for technology that we currently understand is impossible or almost so, such as faster-than-light travel. Another wildcard here is something more to do with our technology. It has been suggested prominently by Ray Kurzweil that we are nearing a technological singularity, a point where predicting developing technologies through the achievement of superintelligence becomes impossible and incomprehensible. If this is indeed how technological civilizations develop, almost instantaneously, into supercivilizations, then everything we can speculate about regarding how alien civilizations behave is frankly out the window. So to spin a scenario, imagine an alien civilization that hits generalized artificial intelligence, and that superintelligent mind goes on to very rapidly investigate the universe, learn how everything works, and use that to develop rapidly increasing advancements in technology. And basically, overnight, that civilization goes from our stage of development to the highest possible stage a technological civilization can reach. If this is the case, then any invasion done by a post-singularity civilization would be utterly unpredictable, in everything from motive to the technology used. The saving grace here, however, is that we may be very close to the singularity ourselves. Some say it's already begun, so any such invasion must happen within a few decades, or we may be every bit as advanced and powerful as any other post-singularity civilization. And that might be a reason in itself for invasion, to stop anyone from reaching the singularity, because by achieving it, a species becomes invincible. Number 3. Unwitting pawns in an interstellar war. It could be said that most people that see war aren't combatants, but are merely stuck by circumstance within the conflict zone. As wars on Earth have shown, they often involve countries that would have preferred to not be involved at all. Projecting this beyond Earth and into the galaxy at large, it could be that interstellar space is dominated by politics and warfare, much the same as Earth can be. And if it indeed works that way, there are many scenarios where we could end up in the middle of a conflict. One specific one is the establishment of a protectorate, where one alien civilization occupies Earth in order to protect it from something that it deems to be far worse, an enemy alien civilization. This could look like anything from a robotic or even 3D printed alien army occupying strategic areas of the planet, to automated orbital defense stations or huge Battlestar Galactica starships being built by a von Neumann replicator. The point here is, though, the moment you are under occupation by a superior entity, you no longer call the shots. Number 2. The Forgetful Invasion. Perhaps one of the most scary alien invasion scenarios is that of being in the position of not remembering it ever happened. This could involve very advanced nanotechnology that in principle might be able to implant false memories in a population to think that they had always been occupied, and may by design think favorably of their occupiers, and even worship them as gods, because they've been reprogrammed to do so. Such an invasion may be invisible from the onset, with some release of nanotechnological assemblers in the air that start their work, slowly set things up for the memory changes, and the whole process might unfold before anyone catches on. At the same time, however, that very likely would be detectable by medical science, and also very likely comes with side effects, which if so, the target population would know their minds are being changed, but have no realistic way to stop it in time. And it simply occurs, and that's that. Occupation and control established without the need for ever firing a shot. Number 1. The silent, all-powerful von Neumann dictator. The last entry on this list is the strangest in that it would be an invasion without an actual invasion. It's simply the idea of control by presence. Whenever a lesser advanced civilization comes up against a more advanced civilization, the latter prevails and controls everything. So just by virtue of having an alien probe sitting in your star system, you are already at a disadvantage, and that probe calls the shots whether you like it or not. And while it may appear to be doing nothing, that can change if it doesn't like what you're doing. Any close presence of an alien civilization reduces the Fermi paradox down to just one solution, and it's the worst one, the zoo hypothesis. So whether the probe is silently watching you and not imposing anything on you, it is still by virtue of its more advanced technology ultimately in control. And the odd thing here is that you may not see much from it. You may never know such a probe is there. Or all you may ever see of such an occupation is the occasional sighting of something unidentified in your atmosphere. While leaps and bounds have been made in our understanding of the solar system, it is still a very mysterious place, where new objects within it are discovered each year. This could include very large objects, such as undiscovered outer solar system planets, but also could include very small objects that we may never find. And that's not even getting into the interstellar objects that pass through the solar system all the time, but we are now just able to detect. So here are 10 mysterious hypothesized objects that could exist in the solar system, but come with spooky implications. Number 10. The oligarchs. Planet formation in our solar system is still an unclear process. To this day, there are minor planets in the outer solar system, the Pluto system among them, that are remnants of sorts of the earliest period of planet formation in our solar system. The question is, however, just how many of these objects there are, and how many there were when the planets initially formed. That's unknown, but it's possible that tens of minor planets remain to be found in the outer solar system. But it may be that there was originally many, many more, and they weren't minor. The oligarch theory of planet formation postulates that there may have been hundreds of full-on planets in the solar system, and that the vast majority were either ejected entirely and are now rogue planets wandering the galaxy, or some were flung so far out that they might orbit extremely distantly, taking millions of years to complete their orbits of the Sun. This has an interesting effect. If there really were that many planets originally in the solar system, then Earth would be a remnant of them, and would have been an oligarch itself. It did not get ejected, obviously, but it adds just one more reason to think that this planet might actually be very lucky, having jumped through a surprising and complex series of hoops just to arrive at us. Perhaps we live in a very unlikely star system. The Copernican principle that states that we occupy no special position in the universe may be an error. Maybe we do. Number 9. Hails of comets. Stellar encounters are not rare in the history of our star system. Just 70,000 years ago, a red dwarf passed within our own Oort cloud, and in about 1.4 million years, the star Gliese 710 is expected to also pass through our Oort cloud. These encounters are bound to disrupt objects in the outer solar system, some of them heading into the inner solar system and perhaps on a collision course with Earth. We know that such collisions have happened before. One of them caused the Great End Cretaceous extinction event. But unfortunately, there is a long period of time between where objects disturbed from the outer solar system and stellar encounters begin their journey and when they end it. This is on the order of millions of years, and it becomes at some point very difficult to impossible to determine past stellar encounters between our solar system and other stars. This means that past stellar encounters might have disrupted hails of comets from the outer solar system that could, at any time, be detected heading our way. And, at least right now, we won't see them until it may be too late. What you don't know can hurt you. Number 8. Gna. In 2015, astronomers at the ALMA Observatory reported a series of pulses that seemed to suggest that either a group of sources or a single very fast-moving object produced them. It's thought that it was more likely to be something moving fast, roughly somewhere between Saturn and Uranus, though there is much uncertainty there. That could mean that there is a dwarf planet well within the orbits of the known planets of the solar system. That would be unusual, but not astoundingly so. Many of the moons of the gas and ice giants are such objects that were wandering around and were captured, and perhaps this is one that simply hasn't been captured yet. And there are questions about the actual detection itself. It may have been an error, but there is one possibility that's interesting within the debate. It could also be that a rogue planet is very distantly passing by the solar system and is much larger than a minor planet, perhaps the size of Earth, but much, much further out, as much as 4,000 astronomical units. This rogue planet would be cooking along very rapidly and not be bound to the Sun, but would rather be a wanderer of the galaxy ejected from some other star system. If it were once something else, perhaps an unlucky but once inhabited planet in another star system that got ejected, imagine what we might find there. Number 7. The wow signal distance question. A topic covered on this channel before is the famous wow signal, SETI's best candidate yet for a radio signal potentially of alien origin. And no, it was not due to comets. That hypothesis is often brought up in the comments, but was actually shot down by the scientific community within weeks of it being advanced. One reason for this was the sheer strength of the signal. WOW was extremely powerful, 30 times the background, far more than what might be produced by hydrogen streaming off a comet. But that also leads to some oddities about the WOW signal that haven't often been talked about and are not well known, despite the fame of the signal. Conventional thinking about the WOW signal has been that if it was a signal of alien origin, it was from some distant star system. There are, however, two issues with this. The first is that searches of the areas where the signal might have originated didn't really reveal too many candidates for stars that might have been the origin. The second is the signal strength. To produce that powerful of a signal to cross interstellar distances would require enormous amounts of energy, terawatts at least, and would constitute an enormous beacon that seems unlikely. In fact, it was the most powerful signal that particular radio telescope ever picked up at that frequency around the 1420 MHz hydrogen line, and it operated for decades. The other part of this was just how the radio telescope was set up. Distant radio sources in this telescope, Ohio State's Big Ear Radio Telescope, were distinguishable from close interference signals by fitting the antenna pattern. The scientists involved with the experiment were able to calculate that whatever produced the WOW signal, it had to be located at least half the distance to the moon to fit the pattern. This eliminates almost all possible sources of Earth interference present in the 1970s, along with an international agreement that prohibits broadcasting at the hydrogen line to preserve it for radio astronomy. And if someone did clandestinely broadcast there, they'd have revealed their spy satellite's existence to all of the planet's radio astronomers, including rivals. But halfway the distance to the moon is not far in terms of space, so it may easily be that the WOW signal wasn't all that powerful, it was merely very close, as in within our solar system, but not so close as to be from Earth. Spooky indeed, but there's one more aspect here. The signal was also just slightly above the 1420 MHz line. This could be due to it being intentionally broadcast that way, or it could be a slight blue shift. If it was the latter, then it would mean that whatever produced the WOW signal is slowly moving towards us. Number 6. Many minor planets that might harbor life. One of the great discoveries of the space age has been the existence of an entirely new class of minor planets and moons that instead of having surface oceans, they have subsurface oceans locked under ice where life could, in principle, exist. This started with Jupiter's moon Europa, but now many such moons are known that seem to host liquid water under their ice shells. But this also extends to minor planets. Indeed, Pluto seems to have such an ocean, and indeed has active organic chemistry going on in its atmosphere. This opens up an odd possibility, in that the many known and undiscovered Kuiper Belt objects, minor planets similar to Pluto, might also host oceans and thus possibly life. In principle, that could lead to a situation where more objects hosting life exist in the outer solar system than the inner, despite the very much alive planet we live on. It's also still uncertain as to just what kinds of life could exist in ice shell oceans. One position is that whatever we may find is likely to be microbial, but we also live on a planet where the oceans produced much more than microbes, so it's possible that entire ecosystems of many different species, microscopic to macroscopic, could exist. But our oceans have also produced sharks, and in the past, giant prehistoric megalodon sharks the size of large whales. Who knows what lies beneath these ice shells? To paraphrase 2010, all these worlds are yours except Europa, because it's infested with giant space piranhas with razor-sharp ice teeth. Always send in a robot first. Number 5. Planet 5. One mystery about life on Earth is just how old it is. There is some evidence that it arose during a hypothesized period known as the Late Heavy Bombardment. This is odd to say the least. To expect life to arise on Earth while it was under heavy bombardment by asteroids seems implausible, but there does seem to be evidence for this event preserved on the Moon, though this is in question now, and it's possible that it may have been misinterpreted. And it's also unclear as to just what caused the late heavy bombardment if it indeed happened. One hypothesis includes the past existence of another planet in the solar system. This planet, known as Planet 5, would have been small, about half the size of Mars, and would have been in a semi-stable orbit between the asteroid belt and Mars. After about 600 million years after this hypothetical planet formed, its orbit would have destabilized, sending it into the asteroid belt and disturbing it, causing asteroid material to bombard the inner solar system. And indeed, the star Eta Corvi seems to have this type of process of late heavy bombardment going on right now. What happened to Planet 5 after this is unknown, if it ever existed. The most likely fate for it was that it fell into the sun. Another option was that instead of disturbing the asteroid belt, it impacted Mars, and that was the material that composed the bombardment. But it may also be possible that it was ejected, and this former killer planet is still out there somewhere. Or maybe it never existed at all. Number 4. Prior Earth civilizations. Earth is a planet that constantly renews itself. Everything from volcanic action, plate tectonics and subduction, weathering, etc., all contribute to Earth resurfacing itself constantly. In rare cases, certain past evidence of life can fossilize, but this is actually a rare process, and our fossil record is very incomplete. There are entire species that once lived on this world that we will never know existed, despite our still regularly finding new species of dinosaurs and other animals many times each year. This also goes for our civilization. If we went extinct tomorrow, Earth would begin to break down everything we've ever built, and after about 10,000 years, it would become increasingly difficult to tell we were ever here. After millions of years, there would be very few ways that our past presence could be detected. This opens up the possibility that there may have been past technological species on Earth that either went extinct or left. Probably not, and we've never found evidence for it, but it also can't be ruled out. Fast forward to a concept within SETI for searching for artificial lighting as a technosignature. The idea goes that if we ever saw clear evidence of artificial lighting on the dark sides of exoplanets, it would be distinguishable from anything natural. But this is currently limited by the instrumentation we have, meaning that about the closest we could look for this right now would be Kuiper Belt objects in the outer solar system. Imagine if we found evidence of artificial lighting on a Kuiper Belt object. Highly unlikely to be sure, but if we ever did, given the vastness of space and how difficult it is crossing it, it would be more likely that we were seeing a past Earth civilization that left the planet than it would be seeing an alien civilization that came here and colonized the object. Unlikely, but food for thought, and hopefully, for our sake, they never want their planet back. Number 3. Not of the star system. Our solar system may in some sense seem very isolated, light years away from the current closest star, but there's also the matter of time. This solar system has existed for over 4.5 billion years, which is well enough time many times over for objects from anywhere in the galaxy to travel here. After all, the Milky Way is only about 100,000 light years in diameter. At sublight speeds, that's not very much when you have many billions of years to traverse space. That means that there could be, and likely are, a host of captured interstellar objects in the solar system, ranging from asteroids to comets to even possibly a captured rogue planet, though that's not very likely. And these objects, once discovered and visited, would provide a wealth of information on the composition of other star systems, though we'll probably never know the exact star systems that they originated from. And the same types of objects are already being spotted passing through, but not being captured by the solar system. It's also possible that evidence of intelligent alien life may be present in the solar system, and that our first detection of an alien civilization will be an artifact rather than radio signals. While the Milky Way is vast, it's also very ancient and well old enough for civilizations to have traversed it many times at sublight speeds. That opens up the possibility of von Neumann self-replicating probes to be present in the solar system, and indeed throughout the galaxy. But there's one potential technosignature that's noteworthy here for its longevity, and it's not often mentioned. It's altered asteroids, and these objects are noteworthy because they serve as very long records. In fact, some materials, such as comets from the outer solar system, can be pristine records of not just the early solar system, but a lot of what's happened to them since they formed. Asteroids and comets also happen to be the easiest sources for raw materials in the solar system, due to them having very low gravity. It's much easier to mine iron or even gold or platinum in space than it is mining it on the surface of a planet and having to rocket it up to space. And the signs of past mining would be telltale in that the composition of the asteroid would be unnaturally devoid of whatever it is that was mined, in contrast to the composition of natural asteroids. Compare this to other areas of SETI. For a radio signal, you just have to happen to be looking at just the right time to pick anything up. This means that another civilization has to apparently exist at exactly the time you happen to be capable of radio astronomy. Same with any other technosignature. You have to exist at a time where it's visible. And since technology and civilizations probably don't last forever, that's a tall order, unless there are a whole lot of alien civilizations out there. But with an altered asteroid in the solar system, it would preserve a long-term record, meaning that in our solar system, you only need one alien civilization to pass through, selectively grabbing raw materials at any point in the last 4.5 billion years in principle to know that aliens are, or were, somewhere out there. And that's probably one of the few things we would ever know about the mysterious alien miners from long, long ago. Number 2. The Unknown Lurker. In 1927, experimental radio operator Jorgen Hals noted that in addition to normal radio echoes, there were also long-delayed echoes that didn't seem to have a ready explanation. He contacted several physicists at the time, and no one could come up with an easy explanation. This is because the delays are so long, above 2.7 seconds after the transmission was sent, but can be up to 12 seconds or more. These echoes are still noted to this day, and most theories about their origin revolve around the Earth's ionosphere holding signals between two layers of air, causing the signals to repeatedly circle Earth. Another involves the signal repeatedly bouncing back and forth between the Moon and Earth, making up the elapsed time. Both explanations, however, seem a bit of a stretch. That the Earth's atmosphere could hold a signal for the thousands of times it would need to circle the Earth seems unlikely, yet the echoes exist. There is, however, another option that has been advanced, that there is something out there that is receiving the signals and then broadcasting them back. This idea is known as a Bracewell probe, and the idea is that that is the starting point of first contact. This general idea was also used in the movie Contact, where the aliens first made contact with us by repeating the broadcast of the 1936 Olympics. Thankfully, that particular broadcast is unlikely to have been strong enough to pick up outside of Berlin, much less at a distance in space. To speculate, and remember it's very likely that these echoes are of natural origin, this probe would be pretty close, though the times between different echoes varies widely. By solar system standards, Mars at its closest approach to Earth is close, causing a radio delay of 4 minutes, though it's usually much longer. For an LDE to repeat a signal 12 seconds later, that means that the source is not far, but significantly further than the Moon, regardless of the cause. That's a problem, and here's where we go from spooky to scary. A highly advanced spacefaring alien civilization parking right next to you is the very worst possible thing that could happen to the human species, short of an asteroid extinction, and such a scenario could well include that. It's at that point that you are no longer calling the shots in your star system, and the whole idea of global or national security becomes meaningless, and that there would be no such thing as security. In that sense, thankfully, LDEs are very probably just a trick of the ionosphere. Number 1. The primordial black hole. One interesting development in planetary science of late is that we may be very close to discovering a new planet in the outer solar system. Now, minor planets are known, and many more probably lay undiscovered, but large, proper planets may also be out there. This is, of course, the hypothesis of Planet 9, which would lurk distantly and perturb the motion of objects in the outer solar system. The other is Planet 10, a Mars-sized planet that, if it exists, would explain the mysterious Kuiper Cliff feature of the outer solar system. But one other hypothesis has been advanced, that Planet 9 isn't actually a planet, but a tiny primordial black hole. This would be a black hole about the size of a softball lurking in the outer solar system that would have formed shortly after the Big Bang. On the one hand, it would be fascinating that such an object were so close, but on the other hand, actually finding it would be beyond a needle in a haystack. We'd be close to a black hole without knowing exactly where it was or what it was doing. But then, there's also the theory that the universe itself is actually a white hole, and that everything in our universe spewed out of the other side of a black hole. And then there's the one where certain aspects of the Big Bang look a whole lot like the interior of a black hole. So we may live in one, but sometimes it doesn't. So who knows, but one thing is clear. Being far from a black hole is generally a better thing than being close to one, and we may be much closer to one than we think. Over the centuries, as we've explored the universe from a scientific perspective, it's become clear that we live in one strange environment. Certain things that make perfect sense and are always repeatable present themselves and allow us to do things like build cars, use electricity, and make YouTube videos. But from another perspective, the universe, and indeed the multiverse, should it exist, makes very little intuitive sense and offers possibilities that aren't so clean-cut, and often are a little spooky. So here are 10 spooky possibilities of the multiverse. Number 10. Boltzmann brains. Infinity is a funny thing, because with it comes the implication that if you wait long enough, then anything that's possible, no matter how remote, can and will eventually happen. This is simply because you have an infinite amount of time to wait for a chance occurrence. This all comes from a thought experiment and argument that says that it's more likely for a single thinking brain to briefly form in a void than it is for a thinking brain to form the way it actually did in the universe. While this is debated, it does allow for one odd possibility. If you have infinite time in a universe, whether a dead one or otherwise, then all things possible will eventually come to be by random chance. This includes some type of thinking being randomly popping into existence, at least for a time, including the most powerful supercomputer possible in some kind of a universe. It even allows for such an entity to have false memories of a much longer existence than it actually had. But if such a thing were to pop into existence in a dead universe far further along than ours, then it might look at the blackness and wonder what the universe might once have been like. It may even do so to avoid madness. It could choose to simulate a universe, and perhaps even exist within it, to avoid the cold and the dark of its reality. If such a thing is possible, even marginally so, are we the fever dreams of an otherwise insane supercomputer living in the void of a dead universe running a simulation? I hope not. Number 9. Penrose cosmology. One possibility within cosmology is the question of whether a universe was actually the first one, or another in a potentially infinite series of recurring universes and big bangs. Originating with physicist Roger Penrose, this hypothesis is known as conformal cyclic cosmology, and it offers some interesting possibilities in that it may be possible to detect echoes or ghosts in a way of at least the last of these past universes. It could be that objects like black holes might have left their mark on the current universe and imprinted themselves on the cosmic microwave background radiation. And there are some early indications that this might actually be the case, but one other possibility is a little disconcerting. At the end of the last universe, there may have been highly advanced civilizations present, if the physical rules of that universe were the same as our own. These presumably would have been very ancient civilizations, living at the very end of their universe, and at a technological level perhaps as high as was possible in that universe. If so, they may have developed technologies far beyond what we can imagine, enough that they might have found a way to imprint a message on the CMB that might be detectable. If so, it would be a message of an age in excess of 13.8 billion years, from before our universe existed, from a civilization long sent to extinction by the end of their own. If they had received a similar message in their universe from the past, they might even forward it, perhaps leading to a layered group of messages from previous universes. If it could even be deciphered, I wonder what such a group of messages might say. Could we do such a thing in the far future? Perhaps all we could say is that humans were once here. Number 8. The strange mystery of the present. We live our lives in the present, the now. Anything else is in the immutable past, or lies in our future. But for something so ingrained in our very existence, in reality the present doesn't actually exist. We may perceive it, but the concept is not really present in physics and the rules of the universe itself. But even within our own brains, there really isn't a present either. It takes time for neurons to communicate and message each other, no matter how small that amount of time is. In physics, this becomes far more evident. When looking across vast distances of space, we see objects as they were, not as they are. So when looking at the moon, you see it as it was just over a second ago. When you look at the star Betelgeuse, you see it as it was almost 650 years ago. And given that it's set to go supernova, it may well already have. We just can't see it yet. But then there is the question of the future. No matter what we do, we are always traveling forward into the future. And the universe allows us to speed that up, in a sense, simply by traveling at high relativistic speeds, or getting too close to an immense gravity source like a black hole. But nowhere to be found is the concept of an absolute present. Instead, it's ambiguous. Your present is not my present, and in the end, the present as we perceive it only exists in our heads. Number 7. We might live in a black hole. One possibility in regards to the Big Bang was that it was in fact a result of the formation of a black hole in another universe. This is actually a more attractive idea than it might seem, since it does solve many of the problems presented by the Big Bang, but not all. The concept involves Einstein's general relativity, which fundamentally links space and time to the point that under extreme conditions, such as inside a black hole, time and space can essentially switch places, or at least become ambiguous. This is important in answering questions like where in the universe did the Big Bang actually occur, since we think of giant explosions as having an origin point. But this is not the case with the Big Bang. Its origin point lies not anywhere in space, but in time. Think of it like this. The universe is like the surface of an expanding balloon. The point where the balloon started to inflate is inside the balloon, and is not anywhere on its surface. So the inside of the balloon represents the past, but not a physical origin point from the perspective of the surface of the balloon for where it actually started to inflate. This leads us to relativity. An observer outside a black hole can see it as occupying a physical point in space. The black hole has a location, but once inside the black hole, its location is not a point in space, but rather a point in time. As you move towards the singularity inside the black hole, it can be said you are traveling towards the future. But relativity breaks down here, so we can only guess what happens when you actually get to that singularity. We only know that the singularity lies in your future, no matter what. It may be that this is the creation of a new universe, where all of the matter that the black hole has ever accumulated gets expelled out into a new environment of space-time. One thing among others that this model addresses is the so-called horizon problem with the cosmic background radiation, which shows us that the early universe was really homogeneous when it shouldn't have been. Now, the natural question is, could you travel to another universe through a black hole? Not likely. It would scramble any information sent through it, including you. And there are still some questions that the black hole universe idea doesn't explain well. But if it is the case, then we are, in a sense, living inside a black hole. Number 6. Many worlds. What exactly constitutes our worldview? It seems clean-cut, reality. But what if every time something in the universe changed, even on a quantum mechanical scale, then a new reality, or a new universe, was formed and split off from the universe we know? This is the many worlds interpretation, and could mean that your reality is always splitting off into alternate, sometimes very different realities. This would lead to a dizzying array of countless other universes all sitting right beside each other. One might be different from another only based on the position of an atom, or entirely different realities where you exist, but under very different conditions, living a very different life. You may own a different car, or have a completely different job, or even more broadly, in another universe, human civilization may have occurred earlier or developed more rapidly and might be a galaxy-spanning empire. Or civilization may not have developed at all, and humans in another universe may still live in Stone Age conditions, or may never have evolved sufficient intelligence for technology, or we may never have existed at all, and the alternate world is still ruled by dinosaurs and their descendants, perhaps intelligent and spacefaring in their own right, all because in that universe their extinction asteroid missed. The scenarios possible under the many worlds interpretation are many indeed. Number 5. The infinite universe. If the many worlds interpretation isn't strange enough, it turns out that it's not the only way for infinite varying copies of you to exist. This take on it stems from an open question within cosmology. Just how large is the universe? The answer is we don't know, and may never be able to know because, well, we can't see that far. We essentially view a bubble of the universe, known as the observable universe, because it's what we can observe given that light has only had a finite time to travel to us since the Big Bang. But we know that the observable universe isn't all that's out there. The part of the universe that we can't observe could extend only a little further than what we can see, or it could be much, much larger. And there is increasing evidence that it is indeed much, much larger. And there may be no limit. It could stretch on to infinity. We simply cannot see enough of the universe to answer the question. If it is infinite, then many worlds becomes possible again in a different way. In an infinite universe, if you travel in one direction long enough, you will come across a very similar, perhaps even almost exact set of circumstances from where you've previously been, such as Earth. This allows for planets very similar but still different from Earth. But given that it's infinity, it also allows for planets nearly identical to Earth, filled with humans nearly identical to us, doing nearly identical things. Go further and you'll see another such variant, and onward to infinity, meaning that there are an infinite number of such variants of you. This would also work for any alien civilizations you might come across along the way. You might find a planet full of intelligent aliens, and then see an almost identical variant the further you go. This would be a scary prospect if it were some all-powerful, hostile machine civilization that you barely survived an encounter with. only to encounter the same thing again, only slightly different. While it has never been established if the universe is finite or infinite, there is the problem of just how far you would have to go just to encounter a copy of you. It is beyond immense, so much so you likely could never reach the closest copy of yourself. And while controversial, the idea of an infinite universe is probably no more likely than a finite one. But one thing seems certain: the universe itself is likely much, much larger than what we can see, and as such, there will be parts of the universe that we will never be able to know anything about. Number 4. Only one universe. Perhaps even stranger than the idea of many worlds or an infinite universe is the concept that this universe is the only one. This would be a situation where there is no multiverse, there is only the universe. And if it is finite, then it truly is all that there is. That's not too disturbing, and indeed has been a standard way of looking at things for a long time. After all, the word universe implies all that there is, has been, or ever will be. The problem is that the universe doesn't have to be the way that it is, so far as we know. There are a number of values governing the universe that, if they were slightly different, then the nature and behavior of matter and the laws of physics might be radically different. One wrong value, and matter itself might not even be able to exist as it does. Even the universe itself might not exist, and under different conditions might collapse back in on itself shortly after forming. Yet the universe exists, and so does matter. Then you come to life. Once again, a number of factors had to be just so for the universe to support life. Then, once again, yet even more factors had to be right to form intelligent life, us. And even more factors played in to make it possible for us to study the universe and attempt to understand it. And all of this had to have happened at exactly this time, since earlier in the universe's history, the matter needed to form planets didn't yet exist, and wouldn't if the universe didn't allow for stars to form. It's been argued that this problem goes away if the multiverse exists. We simply live in the universe that won a lottery as far as the conditions needed to support life go. Most other universes might not be so nice. If there isn't a multiverse, then ultimately all these ideas, known generally as the anthropic principle, accomplish is to say that the universe must be a certain way for us to even be here observing it. The universe allows for our existence. It doesn't really say more than that, but it does give us clues in understanding the universe. But nevertheless, speculating beyond that does paint a somewhat spooky picture of the conditions we live in, to the point that our very existence is highly unlikely. Yet, here we are. Number 3. Other dimensions. Our day-to-day existence is governed by dimensions. We move through our three-dimensional world, but there is also time, which is usually counted as a dimension of its own, where we are always moving forward in it. But it's been long suspected that there are other dimensions that are not so readily evident. String theory, for example, envisions a 10-dimensional universe, M-theory 11, and others. And there are hypotheses that state that things like dark matter might be matter in another dimension interacting gravitationally with the universe we see. What these dimensions represent, however, is not so clear. For example, some suggestions for the existence of these dimensions include that some of them are invisible to us simply because they are curled up, and may have been more evident at the beginning of the universe. Other options are that wormholes, should they prove to be possible, represent tunnels through another dimension connecting 2 points in spacetime, or even as an explanation for spooky action at a distance, where 2 particles may be linked across vast amounts of space in what we see, but in another dimension may be much more closely connected. What this might mean and whether we could ever make use of these other dimensions is not yet clear, and probably won't be without a much more complete description of the universe. Number 2. The destruction of the universe. One particularly spooky question about the multiverse is, do individual universes end? What will be the ultimate fate of our universe, everything that is? This is not certain, but one take is that it will simply become a cinder universe, full of evaporating black holes and iron stars that will simply fade away into infinite darkness and a heat death, where there just isn't enough available energy anymore to drive entropy. Or, at some point, it could all start over with another Big Bang event. But there are some ways it might end before that time. One involves the stability of the proton. Protons appear to be very stable things, apparently capable of lasting for untold amounts of time. But maybe not forever. In fact, a lot of theoretical physics might be incorrect if they don't eventually decay. Eventually could be septillion years from now or far more, but eventually. This would mean that the universe would at some point in the distant future decay. But there's also a way the end of the universe could come much faster. We don't know if the universe exists at its lowest energy state. Think of it like this. You roll a bowling ball down the side of a mountain, and halfway down it gets stuck precariously on a ledge. There the bowling ball sits, not having fallen completely to the bottom of the mountain. But say there is a wind gust or a passing bird accidentally brushes the bowling ball with its wing, just enough to push it off the ledge. Then the bowling ball continues down until it reaches the bottom of the mountain and stops there, and there is no way for it to go any further. The universe may be a bowling ball on a ledge, and if some event upsets the current state of affairs, the universe could tunnel to a lower energy state. This would be catastrophic on an almost unimaginable scale. It would lead to a wave of destruction propagating through the universe at the speed of light, for which there would be no warning beforehand. Left in its wake would be new, altered laws of physics, matter in a different configuration, and everything we know would be utterly destroyed and reconfigured. The only consolation in this scenario is that it would occur at the speed of light, as fast can be, so we'd never know what hit us. Number 1. The unexplained. One big problem with the multiverse, and indeed the universe, is that as much as we try, there are mysteries that we may simply never be able to solve. The multiverse itself is one, since it may not be possible to ever meaningfully measure it. We may never even know anything about it if it even exists. And as far as the universe goes, there are many unanswered questions that may always remain unanswered. So here are just a few of the open questions within physics that we may never understand. Why does time move forward? The arrow only points in one direction, the future, but there's seemingly no reason for this other than entropy. Most other things, such as gravity, can be run backwards and look the same. Another question is the nature of dark matter and dark energy. We see the effects of both in the universe, but not what's actually creating the effect. It's possible that they are forms of matter and energy, but it's also been suggested that they might instead be the effects of a fifth unknown force in the universe. Why is there far more matter in the universe than antimatter? Why does the moon almost perfectly eclipse the sun from the vantage point of Earth, right exactly at the same time that there happens to be a civilization living on Earth that can understand what it is? The list goes on, but as one final mystery to make you go, on this fine Halloween evening, I offer one more perhaps unexplainable feature of this universe. It's called the axis of evil, and it represents a strange feature in the cosmic microwave background radiation. This radiation should be the same any direction we look, and it is, mostly. The same goes for the universe. It should look more or less the same in any direction we look, and it does, mostly. This is the Copernican principle, that we have no particularly special vantage point in the universe. But maybe that's wrong. The cosmic microwave background radiation does have some anomalies. For example, one half of what we see is very slightly cooler than the other half, and there are others, and they all correlate to the plane of our solar system. This should not be, and for a long time scientists wondered if there was an observational error, or if things were being interpreted wrong. That was until June of 2020, when the observations of the anomalies were confirmed with a completely different instrument. Apparently, our position in the universe is in some way very special, or at least unlikely. What this means is yet another unknown. In celebration of the Halloween season and a continuing tradition of this channel going back to the early days, here are 10 spooky things that the universe does, or may do, that are currently invisible to us and we have no control over. Number 10. Dark matter. While studying galaxies, it became evident to scientists that the visible material contained within them couldn't account for the observed gravitational effects. This led to a conundrum. Either something was fundamentally wrong with our understanding of gravity and physics in general, with gravity already being murky territory, or there was some unseen and visible, almost entirely non-reactive material in the universe that not only reacted only through gravity, but apparently constitutes the bulk of matter in the universe, as much as 85%. While the existence of dark matter is fairly widely accepted within physics, it's not universally so, and a small contingent of scientists believe that instead there may simply be a problem with our physics on huge scales. This would not be unheard of. Einstein's relativity came out of small discrepancies found within classical Newtonian physics. But if dark matter does exist, it's thought that it may be made up of non-baryonic subatomic particles that have yet to be discovered, and they would be very difficult to discover indeed if they only interact with everything else through gravity. Gravity on the subatomic level is unbelievably weak, but it's interesting to think about the idea that you yourself, right now, are surrounded by an invisible halo of non-interactive material that we know almost nothing about, and there's a chance that we never will. Number 9. Dark energy. Just a few decades ago, it was assumed that the expansion of the universe would eventually slow and stop due to gravity. Subsequent observations by the Hubble Space Telescope blew that out of the water and indicated that in the early universe, the expansion was actually slower than it is today. The predominant explanation for this is dark energy that drives the expansion of the universe to faster rates, and based on observation, it can be estimated how much energy is involved. As it turns out, a lot. It's estimated that about 68% of the universe is dark energy. Dark matter is about 27%, and only about 5% is normal matter, which actually means that normal matter is actually the abnormal part of the universe. But that's about all that is known. What this energy is and what it might imply are still mysteries. Possibilities are that it is energy inherent to space itself. Space, while it may seem like the ultimate nothing, is actually more of a something, and may be able to have its own energy, which would be spread evenly across it. Since space is expanding, or in other words being created, more of this energy should come into existence as the universe ages and expands. What all this means, and even if we'll ever even know what dark energy is, remains to be seen. Number 8. The Great Attractor. Our galaxy is unfortunately very difficult to see through when you look straight at it through its plane. Step outside some night and look at the Milky Way. It stretches across the sky, and we see it as a member of that galaxy sitting out in a suburban location near a spiral arm. What's difficult is seeing through the galaxy from our perspective, as much dust, gas, and stars lay in the way. Behind that mess, however, is something that we cannot directly see, but we certainly see the effects of. It is the gravitational anomaly known as the Great Attractor. The Milky Way is located in a supercluster of galaxies. The center of this supercluster is obscured by the Milky Way, but shows evidence of something with a mass thousands of times the Milky Way lurking there. Astronomers see the effect of this anomaly in the motions and redshifts of galaxies and clusters of galaxies over a massive region of hundreds of millions of light years. They are being attracted towards the anomaly and seem to be being affected by a second phenomenon called dark flow, a non-random acceleration towards the attractor above what gravity might be doing alone. More recent work suggests that the attractor is a huge cluster of galaxies at the center of the greater cluster, not an unexpected state of affairs. But ideas like dark flow seem like an open door for further future mysteries regarding the movements of galaxies. Number 7. Aliens and the unobservable universe. Depending on who you ask, intelligent life in the universe is either very, very rare or not. On the one hand, there's no reason that Earth should be special, and there's no reason that we should be unique. Quite the opposite. Odds are there are, were, or will be other civilizations in the universe, given the sheer number of chances for it to happen. After all, there are an estimated 1 billion trillion stars in the observable universe alone, and that's just the observable universe. We can only see part of it, and we don't know how big it actually is, and it could even be infinite. In which case, there aren't only aliens, but copies of you, or someday will be, almost exactly the same, located an infinite amount of times across an infinite universe. Same goes for any alien civilizations that might be out there. Point is, it doesn't seem likely that we would be alone whether the universe is infinite or not, but wherever we look, we have yet to see a single shred of irrefutable evidence of an alien civilization. Yet, the fact that we exist shows that such things are possible. This inevitably leads us to the Fermi paradox, the question of where is everyone? Solutions to this range from the odds being such that civilizations within a single galaxy rarely exist at the same time, or that advanced alien civilizations don't look like what we envision them to, or simply that the aliens are hiding their presence from us, along with tens of other plausible solutions to the paradox. But say they're simply hiding. Do they just wish to not interact with us? Or are they waiting out there for us to venture into space? If so, what are their intentions? Number 6. The invisible death from outer space. About 440 million years ago, a mass extinction event occurred on planet Earth that seems to have been very different from the other major mass extinction events that have happened here. While there are a number of hypotheses that might fit the cause of this extinction, one of the worst Earth has ever seen, one idea that's consistent with the beginning of the extinction cascade is that a high-energy gamma ray burst originating from far outside the solar system almost instantaneously burned off half of Earth's ozone layer, exposing surface or near-surface dwelling organisms to very high levels of ultraviolet light, causing their extinction. One possible explanation for this is the occurrence of a hypernova about 6,000 light-years from Earth. While there is no solid evidence for this occurrence, it merely fits the bill, future gamma ray bursts within the Milky Way do pose a threat to life on Earth. There are actually several different identified types of gamma ray burst, and depending on circumstances, there are two ways they can kill Earth life. One is the aforementioned rapid depletion of the ozone layer, but if coupled with a release of cosmic rays, they could irradiate the surface directly, essentially killing a large portion of the surface life of the planet through radiation sickness. This brings up a star known as WR104, which may pose a threat. This system, which is about 7,400 light-years away, is set to produce at least one gamma ray burst within the next 300,000 years. If the relativistic jet from this burst is pointed at Earth, which there is some indication that it might be, then it could pose a threat to Earth and eventually cause a mass extinction, and we may never see it coming. Number 5. Panspermic microbes. The microbial world is notoriously difficult to see, at least without the right equipment, but it's very evident in such things as food spoilage and infections. But we also know that some of the microbes represent the epitome of resilience of planet Earth, with species that have been identified that can withstand very high amounts of radiation, orders of magnitude more than a human, and even species that can completely dry out and remain dormant for very long periods of time. Because of this resiliency, it has been suggested that microbes might be able to survive traversing space inside rocks, at least to other bodies in the solar system, and conceivably further. While no evidence of this has yet been seen, it's not that far of a stretch to suggest that life might have appeared on bodies like Venus or Mars just as easily as Earth in their past history, or for that matter bodies like Europa or even Titan. This opens up the possibility that microbes from another world might end up deposited on Earth unseen, or it's also possible that life on Earth originated from somewhere else and was transported here. Who knows where we are originally from? Number 4. Outside the simulation. One somewhat vexing possibility with the universe is that it may not be real in the sense of an actual universe, but instead is a simulation. On the one hand, it doesn't intuitively seem like one, and if it were a simulation, it seems rather expensive and wasteful. On the other hand, if it's some kind of ancestor simulation, an argument put forth by Nick Bostrom, that one of three things must be true. Either the number of civilizations that can create such a simulation is nearly zero, or the number of civilizations that choose to do something like that is nearly zero, and if not those, then it becomes likely that you do live in a simulation. So given that line of thinking, if it is a simulation, then what's outside it? Who created it, if anyone? Given that we're in here and all of that is out there, it's unlikely that we'll ever know. Number 3. Vacuum decay. The universe is permeated with quantum fields that essentially hold reality together. While most of these fields appear to be stable, there's one that might not be. It's the Higgs field and its associated particle, and they are what lend mass to the universe. What's uncertain about the Higgs field is if it's actually stable. Think of it like this. You are on a mountaintop holding a bowling ball. You roll the ball down the hill, but it becomes stuck, say in a small valley or ditch. There's plenty more mountain to go down, the ball just can't get there without something agitating it and getting it rolling again. That may be the case with the Higgs field, and it may be analogous to a false vacuum. It may appear stable, but it has more energy than it would like to have. This opens up the possibility of it eventually collapsing to a lower energy state. One way for this to happen likely requires an enormous amount of energy, but another is via quantum tunneling. Could the Higgs field tunnel spontaneously to a lower energy state? Possibly, and if it did, it would be the end of the universe as we know it. As the change in state propagated through the universe at the speed of light, it would leave in its wake a universe with fundamentally changed laws of physics. This might mean that matter as we know it can't exist at all, or chemistry may be dramatically altered, and any number of uncertainties might create an entirely new reality. But one thing is for certain, life almost certainly will not survive it. Number 2. The multiverse and many worlds. One of the most vexing questions within physics today is if there is more than one universe. Much of the reasons for this lies in interpretations of quantum mechanics, but another part of the reason for this thinking is that this universe, given the hundreds of variables and values that allow it to exist as it does, looks a bit strange. If a few things were off, then matter couldn't exist at all, or the laws of physics and chemistry might be radically different. Even the idea of time itself happening to move forward is an open question as to why. And all of this happens to come together in just such a way to not only allow the universe to coherently exist, but for intelligent life to exist within it. That problem goes away in the concept of a multiverse. In that event, there could be many or even an infinite amount of universes. Some might turn out like ours, the vast majority probably not. Some could even just be black expanses where nothing much happens, a fate that's thought to lie for our universe in the very far future. These hypothetical alternative universes take several forms, such as the aforementioned take on the multiverse, but also ideas such as the interior of black holes being gateways to other spin-off universes. But there may be more than that. There is also the many worlds interpretation of the universe, where other realities are constantly splitting off from the universe, leading to different paths determined even by the most minor deviations. There could be many versions of you that ate different breakfasts this morning, or chose a different pair of shoes to wear. While contentious, these interpretations end up more plausible in some ways than the idea of a single, perfectly tuned universe. Any way you cut it, the universe is just weird. Number 1. In the future, no one will see much of anything. We exist at a lucky time in the universe, one where we can look out and see stars and galaxies, at least part of the universe anyway, and it's probably a good thing that we're here to photograph and study it, because in the far future it will be next to impossible to see much of anything out there. As the universe ages, bright star formation will slow and come to an end. Only the very longest-lived stars, the red dwarfs, will continue on. But they are dim by nature, and as they become the sole functioning stars in the ever-expanding universe, the galaxies will disappear from the skies, as will the stars themselves. Any civilizations present during this era may not even know there's a universe out there at all. They would only see blackness, and their ability to do cosmology will be severely hampered. They may not even be able to find out how the universe began. This state of the future universe has an interesting implication. If one hypothesis is correct, we're actually very early in the game as far as civilizations go, thus providing a solution to the Fermi paradox, the question of where is everyone? This could imply that over time, the amount of civilizations will rise, and if old ones, such as ourselves, don't go extinct, there could be an explosion of intelligence in the universe more or less right about the time that the stars start blinking out. To these civilizations, the universe might mostly be a mystery, and they might never know how it all began. In keeping with the Halloween season, here are 10 spooky scientific concepts and discoveries that may have implications that not only do we not currently fully understand, some of them may never be understandable at all. Number 10. The anthropic principle. Human life exists. That's something we cannot refute because, well, we're certainly here. That means that our universe is fine-tuned just so that it allows for human life and perhaps most importantly, consciousness to exist. We're not sure why this is, and attempts by science to determine some underlying process that governs why the universe is the way it is have been fruitless. It's not perfect for life for any particular reason, it just is. This is known as the fine-tuning problem. There are a number of different values in the universe that are very narrow. They must be very tightly defined for the universe to work at all. The trouble is, there doesn't appear to be a reason for why these values are set the way they are. For example, if the strong nuclear force were just a bit stronger or just a bit weaker, then none of this could exist as it does. What set that value? We don't know. And there are quite a few other values that seem to be set just right. So what does this mean? It probably means one of two things. On the one hand, it could indicate that there are many universes making up a multiverse where we just happen to be in the one where things are just right, but most of the others are probably lifeless and radically different. This seems to fit with advanced physics such as string theory, and there may indeed be potential indicators of other universes. More on that in a minute. But on the other hand, if this is the only universe, then we live in statistically almost impossible conditions. You have a better chance of winning the lottery 10 times in a row over 10 consecutive weeks than for this universe to just happen to be the way it is for no reason. This would support something called simulation theory, which posits that we're all some sort of AI living within a computer simulation. This theory has its merits. See my video, Is the Universe Real, or is it a computer simulation? But if it is a simulation, then who created it? Number 9. Mass extinction. We all know about the potential possibility that an asteroid could strike the Earth and we could go extinct as a result. Increased attention on this threat has led to efforts to track near-Earth asteroids, and if we're smart, we'll develop ways to move asteroids and ensure that this scenario never happens. And while Earth's history has seen a number of mass extinctions, the most famous of which killed the dinosaurs, what a lot of people don't realize is that we're actually in the middle of a mass extinction right now. Called the Holocene extinction, this ongoing event affects almost every family of plants and animals and is the greatest loss of biodiversity since the Cretaceous-Paleogene extinction event that killed the dinosaurs along with 3/4 of the species living on Earth at the time. That event is thought to have been due to an asteroid that had the effect of several million nuclear warheads detonating at once. This new extinction event is nothing close to an asteroid, but it's unique among the extinctions because we're causing it, and we have been for thousands of years. We are linked with the extinction of the Earth's megafauna, such as the mammoths, at the end of the last ice age, and to this day we continue to impact the environment in such a way as to continue the extinctions. In short, as far as threats to life in general are concerned, we're deadly. But there is a silver lining here. Science and intelligence, and using genetics, science does allow us to eventually bring those species back from the dead and restore, plan, and manage Earth's biodiversity. Ethical questions aside, the mammoth may someday walk the Earth once more. Number 8. You are not alone. One of the most interesting theories within science is that there could be alternate, parallel universes in addition to our own. One variant of this theory allows for universes to occupy the same space, hovering just inches away but existing in a kind of higher vibration that makes them invisible. While highly speculative, it's possible that just inches away from you could be another universe. Perhaps another Earth exists in that universe, occupying the same space. There could be people or other creatures that you can't see in the same room with you at all times, and you'd never know it. Number 7. Gravity is not of this universe. One of the most elusive mysteries in science is the nature of gravity. Einstein himself spent much of his later career trying to understand it to no avail, and now, years later, we still do not have a successful quantum theory of gravity. That's led to much speculation within science that steps outside the boundaries of quantum physics and into someplace else. One potential theory of gravity suggests that the reason gravity is so difficult to understand is because it's not native to our universe at all and is simply leaking into it from a parallel universe that we know nothing about. Number 6. The Great Void. There is a strange 330 million light-year region of space that is almost completely devoid of galaxies. Voids in space are not unheard of. Galaxies attract each other through gravitation and areas empty out, but none of them are anywhere near as big as the Great Void. In fact, it's so large that there hasn't been enough time since the Big Bang for such a huge void to form. So what caused it? One theory is that it formed as a group of smaller voids coalesced. That's probably the case, but there is another theory that takes us into strange territory indeed. It is possible, though beyond highly unlikely, that the void could be due to a Kardashev Type 3 civilization expanding outward, building Dyson spheres. As they build them, the stars inside would appear to blink out. This could explain the void's remarkably spherical shape. However, such a civilization would be easily detected by searching the void for infrared radiation consistent with Dyson spheres. So far, this has not been detected, nor has the question of the viability of completely encasing a star in a Dyson shell been settled. Number 5. The end of the universe. Can the universe simply blink out of existence one day? Frighteningly, it may be possible. There are two ways for the universe to just go away. The first is the false vacuum theory. This somewhat complicated theory is based on a question we don't know the answer to. If the universe exists in its lowest energy state, then it won't happen. If it doesn't, then the universe could suddenly tunnel into a lower energy state and the false vacuum state collapses. This would potentially alter our universe instantaneously to a state where matter can no longer exist. Everything would simply cease to exist in less than the blink of an eye. The second involves simulation theory. If this is all a computer simulation, whoever is running it can presumably shut it down anytime they wish. Number 4. The Great Cold Spot. The Great Void may not be alone in the universe. In the constellation Eridanus lies a strange, very cold region of space where the cosmic background radiation is very weak. We don't know why this is. Most generally accepted theoretical models don't allow for it, yet there it is. One unlikely possibility is that it formed during the Big Bang, but there are problems with that. Another possibility is that a huge void is causing it, similar to the Great Void mentioned earlier, but there are problems with this theory as well. But one theory takes things a step further. It has been suggested that the cold spot could be an imprint from a parallel universe beyond our own. This is actually an attractive possibility because it would support string theory, and it may be testable to determine if this is evidence of parallel universes. The theory goes that there should be a similar cold spot at the opposite end of the universe. This has not been observed, but complex computer modeling shows that it should be there. Number 3. The slate-wiping extraterrestrial virus. If there is other life in the universe, it's safe to assume that the vast majority of it will be microbial in nature. Because of this, since the early days of space exploration, NASA has gone to great lengths to ensure that our astronauts returning from the moon and any samples from space have been quarantined just in case there was life hiding in them. There is an excellent reason for this. Such things, like their earthly counterparts, could make us sick or even extinct. There really is no way to know what might happen if alien viruses escaped containment. They might not do well in our environment and be killed off by Earth life, War of the Worlds style, or be incompatible with all forms of life on Earth, or they may be favored by our environment and life on Earth becomes easy pickings with no hope of developing immunity. Unfortunately for us, there is one area of this question where we have no defenses: meteorites. In theory, meteorites can ferry living organisms from planet to planet, and unlike asteroids, we really can't predict when or where they are going to fall. Tons of them fall every month, most of them plunging into the ocean, any one of them carrying potential contamination. Number 2. Dark matter and dark energy. Dark matter is invisible. It does not interact with light and cannot be directly seen, despite being a large portion of the existing matter and energy in the universe, about 26.8%. How we see it is through its gravity acting on the universe, which has profound effects on the structure of galaxies and the formation of the universe. While we have some ideas on what dark matter might be, such as weakly interacting subatomic particles, ultimately they are just that, ideas, and other than gravity we know almost nothing about this stuff and what implications it might have on the universe long term. Even stranger is dark energy. It seems to permeate space itself and drives and accelerates the expansion of the universe. And there's a lot of it, making up nearly 70% of the energy in the universe. Whether this energy can be used or what implications it has on the universe's future remain largely unknown. Number 1. Dark flow. This phenomenon may well be the weirdest in the universe, if it exists at all. That is somewhat disputed. At first glance, it just appears to be a certain movement seen in galaxy clusters. They seem to move in a common direction. Standard models say that this should not be so. The motion should be random in all directions, but it's not. There are several possible explanations. The motion may be an effect of something that happened before the 380,000-year brick wall, where before that we can't see what happened during the Big Bang, but it could also be something very different. Scientists at NASA's Goddard Space Center proposed that the flow could be due to another universe tugging on the galaxies, or perhaps an area of spacetime that is significantly different than what we're used to, that runs on a completely different set of rules. We simply do not know what is out there.
It's not over yet. Join me as we continue to travel through the cosmos on a gentle wave into another episode of Event Horizon with your host, John Michael Godier.
Dr. Geraint Lewis, welcome back to the program.
Hello, how's it going?
Good. Now, Doctor, you've recently been working in something that's really interesting. Now, a lot of people understand the idea of time dilation and, relativity and those things, like, that part of it. But there's also the idea of cosmological time dilation. Can you lay that out for us?
Yeah, so we go back to Einstein's general theory of relativity, and of course, the thing that we know, that the sort of common story is that one of the consequences is that time runs differently for different observers, and so there's no universal clock, there's no sort of way that we can all sync our clocks together in a simple way, and what Einstein told us, of course, is firstly that clocks for people moving at different speeds, they run differently. general relativity says that clocks at different locations in a gravitational field run differently. So a clock on the Earth runs differently to a clock that's orbiting on a satellite. But one of the other consequences of the equations of relativity is that when we look at clocks spread throughout an expanding universe, we should see those clocks run differently. And so what we have is that we live in this expanding universe. And if you want to think about it, it's like space-time today is different to the space-time yesterday. And that difference in space-time means that when we look back and we see clocks in the past, we should see their ticks run slower. And the further back we look, the slower and slower the apparent clock tick would appear. So this cosmological time dilation, it's been known for quite a while. Excuse me, I lost my voice there for a moment. It's been known for quite a while in terms of the theoretical expectations, but it took us up until around the 2000s to actually start to measure cosmological time dilation. So this is looking out into the universe, looking for objects that we can use as clocks. So we need to find objects that we can think have some sort of standard tick that we can measure, and then seeing how their tick is dilated as we look further and further back into the universe.
Now, pulsars, how does that play into this? Are those the clocks?
Well, pulsars would be useful clocks. So pulsars, of course, are these tiny little, very dense stars, which are rotating very quickly, and they send out pulses at very regular intervals. But the problem we have with pulsars is that they're not very bright. And so we can only really see pulsars as clocks in the relatively local universe. So we don't see pulsars far enough away for us to measure the effects of the expanding space between us and the pulsar. Maybe with future radio telescopes that can peer more deeply into the universe, we'll be able to pick up the tick, tick, tick of pulsars, which are far enough away to measure this. But at the moment, we just don't have the sensitivity.
Now, what if something really powerful, like a quasar?
Yes. So I should mention firstly that we can go somewhere in between first. So there are exploding stars called supernova. So they are the ones that people have used in the past as some sort of cosmic clock. And a supernova is a big star that explodes, and that explosion plays out in a almost identical fashion for each supernova. So they brighten very quickly and then they fade away over some sort of time scale, a matter of weeks. And there was a project that was started in the 1990s to measure the expansion rate of the universe. And they were looking at supernova. And so we're looking at the rate at which they brightened and faded. And so they said that they had detected this time dilation, that supernova they were looking at, which were roughly, explosions were roughly 5 billion years ago, their explosions were running at roughly, they were slowed down by a factor of 2. So instead of taking 2 weeks to brighten and fade, they were taking roughly a month. So there was this detection of the cosmological time dilation, but still only about half the age of the universe. Now, there are other variable objects in the universe, and some of them are very bright. And the one you mentioned there are quasars, which is something that I've been working on for a number of years. So quasars are these supermassive black holes. So they're black holes with masses of order 1 billion times the mass of the sun. And around those black holes, you have material swirling around. So this material is going around really quickly, approaching light speeds. And if you can imagine, you've got material moving really quickly, stuff is rubbing against stuff. The material gets very, very hot and glows very, very brightly. So these quasars, as they called, they were discovered in the 1960s, and now we can see them basically, all the way back over to almost the furthest we can see. So we can see quasars over more than 10 billion light years away. Now, quasars vary. You can imagine those accretion disk material is swirling around. That material has turbulence. Things are popping and bubbling away. And that causes the brightness of these quasars to vary. So they get bright and they get dim, and they get bright and dim, etc. And the question has been for a while that if I see a nearby quasar, it should be, its light should be flickering in a certain way. If I look at a more distant quasar, I should expect to see a similar kind of flickering, but but now dilated due to the expansion of the universe. So people have looked for this quasar time dilation for several decades, and there was a big mystery because they basically failed to find it. They had their quasars, they measured their brightness fluctuations, and they couldn't see any signal that nearby quasars were varying in one fashion, and distant quasars were varying in a similar fashion but time dilated. So this was a bit of a mystery, and what it did, of course, is it led some people to suggest that maybe these objects, these quasars, are not truly supermassive black holes and are not truly billions of light years away. Maybe we have been fooling ourselves. Maybe they're actually in the nearby universe, and that's why we don't see the effect of the expansion of space-time between us and them. So this was the situation up until the end of last year. And what happened is a group in the US, they published a new set of data on these quasars. So we know tens of thousands to hundreds of thousands of quasars that are out there, but these guys focused on only 200 of them. And the reason that they have that focus is that these quasars were located in the same patch of sky. And the project, which had been underway for several decades, had gone back time and time again and observed these quasars. So they looked at the quasars, and they had different telescopes, and they got images of the quasars over this time scale, and they measured the brightness. And so they got the light curves, the flickering of each of these quasars. Now, what was kind of interesting is that in that time period where they were gathering the data, a few things had changed. Firstly, we had actually started to get a handle on just how quasars varied in their brightness. So they're not like they're not like a lighthouse, which is flash on, flash off, flash on, flash off. Their brightness variability is a lot more like the stock market, right? It ups and downs and on various scales, sometimes doing something for a long period and sometimes very rapidly. And we had managed to get a statistical handle on the brightness variability of quasars. It's something known as a damped random walk for people that understand this kind of variability. And so I got hold of this data, and I thought to myself, if we are able to characterize the quasar's variability in terms of a damped random walk, maybe I can use that as the standard tick that we can use to try and measure cosmological time dilation. But there was another problem in that quasars come in lots of different varieties. Some are bright, some are faint. And when we observe those quasars, we're not always observing them on exactly the same sort of scale. But luckily, this data set was good enough that I was able to group together quasars based upon their properties, how bright they were and how we were observing them. And again, so over Christmas, New Year, at the start of this year, I was able to dig into the statistics of the variability and hunt around, and I said, put quasars on an equal footing. And one thing that popped out of the data more or less immediately is that there was a difference between the variability for nearby quasars and more distant quasars. And that variability was precisely the cosmological time dilation that people had missed in the past. So we were able to show that, yes, we have this cosmological time dilation effect. And because quasars are much brighter than supernova, we could observe them over 90% the age of the universe. So we were able to look back, and the most distant quasars we were seeing, their time was basically ticking away 5 times slower than time in the local universe. So that was a pretty cool result, really.
Unfolding 5 times slower than what it actually did. That's absolutely amazing.
Yeah.
Now, quasars themselves. So, do we really understand the mechanism of what a quasar is? And is it possible that there was a time where the Milky Way was a quasar, and somebody way out there in an extragalactic situation is looking at the Milky Way, measuring cosmological time dilation?
Well, so firstly, quasars are complicated places. My wife used to work on the physics of quasar accretion disks, and I can tell you now that when you have material which is super hot, moving at super high speeds, the physics gets very, very complicated. but we do have a handle on the kind of mechanisms of things that are going on in that sort of swirling accretion disk. As you can imagine, the material is so hot that it's a plasma rather than normal gas. And when you have plasmas, you have strong magnetic fields, and so you get physics like the physics we get on the surface of the sun. You get outbursts and all that kind of thing. So we don't understand the detail, but we are getting to grips with the complicated physics. Now, the question of whether the Milky Way was a quasar is a very interesting one. Firstly, we know that the black hole in the middle of the Milky Way is big. It's roughly 4 million times the mass of the sun, but it's not super big. It's not billions of times. So there probably was a period when the Milky Way's black hole was feeding. It was eating gas, and that gas glowed brightly. But it may not have reached the scale, may not have reached the power output of some of these really highly luminous quasars that we see. There's actually a very nice little science fiction book from the 1960s or 70s written by Fred Hoyle, who was, of course, a very famous cosmologist. And he basically was thinking about this, and in his story, it's set in the modern day. But what happens is that the black hole in the middle of the Milky Way starts feeding and starts to glow and starts to output a lot of energy. And that starts to have rather dramatic influence on the Earth, right? Because we have got all this extra radiation arriving. And people have to basically move to the Northern Hemisphere, basically get up to Scotland to get away from that extra radiation that's coming from the galactic center. And if you think about it, it might be good that the Milky Way may not have ever gone through that quasar stage, because if the output was really at the scale that we see in quasars, maybe that would basically prevent that host galaxy from ever hosting life. If it's putting out so much radiation that planets themselves are starting to get highly irradiated, maybe it's the fact that we didn't go through that quasar stage is one of the reasons that we're here at all.
Now, a hypothetical situation as we grow in our understanding of quasars is, say you get a situation where a quasar can turn back on by way of a galactic merger or something like that, where the black hole gets new material to eat up. Is that an extinction event? I mean, would that cause the extinction of most species in a galaxy? Should that happen?
Yeah. This is a question people have thought a lot about the how much the galactic environment influences the possibility of life forming on a planet in a galaxy, and people have some have come to this conclusion that maybe we are here because our Milky Way has basically had a quiet life. It hasn't had a violent collision. It hasn't had one of those periods where we've had this massive output of radiation due to it going through an active galaxy stage. So yeah, it could be that the galaxies that we are seeing that are hosting quasars, maybe those ones are dead and sterile because they've been through this really sort of apocalyptic event, and we're lucky because we're in a relatively quiet galaxy.
Yeah, it's interesting because, the Fermi paradox starts to dissolve a bit when you start taking into factors that not only do you have things like the rare Earth hypothesis, but what about the rare galaxy hypothesis, where the Milky Way is just unusually quiescent and the conditions of the galaxy itself were necessary for life to, get a start here.
Yeah, and in fact, there's people who now talk about a galaxy habitable zone. So in our Milky Way galaxy, we sort of know that life in the middle of the Milky Way would be very tricky because the orbits bring stars very close. You get lots of supernova going off. It's a kind of one of those sort of active environments. Whereas in the outskirts of the Milky Way, star formation has been too quiescent, and there are relatively few heavy elements. So maybe there are not the elements we need to form planets and life in the outer regions. So we find our sun in the galactic habitable zone. But there are other things that can happen in a galaxy. You can get not only exploding stars in the form of supernova, but we know we also get hypernova and gamma ray bursts and fast radio bursts. And again, maybe the Milky Way has been lucky and we haven't had one of those close enough to us that it could have been, an apocalyptic event and an extinction of all life on the planet.
Another interesting issue that's popped up recently in astrobiology is the phosphorus problem, and that phosphorus may not be distributed evenly, even in the Milky Way, which
Yes.
adds a further constraint onto it. And then you got questions of, do you need a moon with tides and things like that? But you always have wild cards like the ice shell moons, Europa and Enceladus, and that sort of a situation where maybe it can happen a completely different way. But can you imagine that where you got some shielding because you got all that ice, Can you imagine a situation where the universe it is a place of life and a boat of life, but it almost never happens on a terrestrial planet. It's always in an ice shell, and they're locked in, and they can't do cosmology, and they never know about things like time dilation.
Yes, yeah. I mean, you have to try and rein in your science fiction mind when you think about the possibilities of life. There's not only life, of course, on the surface of a planet, but there's also the life that might be on a water world, right? That lives at the bottom of the ocean. How do they do their cosmology? How could their technology advance, no matter how smart they get? So yeah, my sort of feeling is that I am on the life, like intelligent life, technological life is probably vanishingly rare in the Milky Way galaxy and maybe in the universe as a whole.
It's interesting. It's one of our great mysteries. But another mystery is what exactly is time? Is time a physical concept, or is it just something that we exist in that a clock can differentiate? But other than that, is there a physical time? Now, Einstein sort of skirted this with the idea of space time, but is time a physical thing? Is it a dimension or something like that, or is it just something that we perceive, which has no actual reality?
Yeah, I mean, look, this is a difficult question, and it leads to all kinds of philosophical arguments. And I'm teaching general relativity and cosmology at the moment to my fourth year students, and we talk about the concept of time and the concept of time in relativity, and the notion that we had of time. So like when we start our university education in physics, right? Time is taken as a given. It's something that ticks off, and we can set all of our physics with regards to the fact that time ticks off from one instant to the next. And we don't really worry about what time is. That's something for the philosophers to get lost in. But then when we get to relativity, and then time, instead of being the background, becomes the stage, right? It's part of the equations. And we have to ask questions about, why does time have a direction? Why is there an experience of time? Because when you write down uh, the universe according to Einstein, time is equivalent to space in the same sense as that, left, right, up, and down, they exist. The time, all of time exists in exactly the same way as all of space does. And then the question of why we experience time as basically unfolding, that's not in the equations. The equations don't say to us that we should expect the future to unfold from the present. The future's already there, and the past is still there, and somehow we are winding our way through this like some sort of, like, you're drawing a pencil on a map. It I don't know. I must admit, it does bother me, and the notion that, again, the future already exists in that relativistic picture, of course, leads to all kinds of weird questions about free will and our choices into the future. If it's already written, then where is free will in all of this? So you have to turn to the people who do quantum mechanics, and they'll say to you things like, oh, we've come up with this picture where time unfolds or is built out of some sort of quantum process, and now is like a sheet that exists in this relativistic picture. But the arguments in my mind, they're not overly compelling at the moment. Uh, are you familiar with a Stephen King story called The Langoliers?
I am indeed. Go
Yeah,
into that.
yeah. So no, the Langoliers is this idea, and it was made into a TV movie, that time exists an instant, as a now. But the past is constantly being consumed by these creatures called the Langoliers that ensure the past no longer exists and the future gets to unfold in front of us. And I think that Stephen King story seems about as reasonable as many of the quantum ideas I've seen people propose to explain how time behaves. Right? We really do not have a very good handle on what time is and why it behaves in the way it does, and why we experience a now, and where does the past go, and where does the future exist. It's still one of those big mysteries.
Indeed, as is the idea of time travel, because it's a double edged sword. Again, because of general relativity, you have time dilation, and which means you can travel into the future. And even just sitting here stationary, we're still traveling into the future,
Hmm.
but not the past. So, what is it? What is the difference between the future and the past, such that the past you can't get to, or at least we can't figure out an easy way to do it, but the future you're stuck with it.
Well, again, I had a really good philosophical chat with my relativity students about this. Again, in the equations of relativity, the definition of future and past is not defined. We have to impose what we think is the future into our equations, but in there, nowhere does it say this direction is the future, that direction is the past. We can choose. We have an arbitrarily choice, and we can flip the past for the future. So we have to ask ourselves, why do we have a direction? Why do we have a direction of time? And I think in my mind, the only sort of answer that I can come up with why this direction exists is that our universe had a beginning. There was a point, a starting point that the universe has, and it played out in a particular direction, and that sets the future and differentiates it from the past. And if we lived in a universe where it didn't start with a big bang, imagine we had a universe that was stretched infinitely far into the past and infinitely far into the future in terms of time, then I think the definition of future may not be a well-posed project, a well-posed, sorry, concept, in that you could have creatures, beings, both move in through this space, but for one of them, they're going backwards in time with respect to the other, if that sort of makes sense. I mean, mathematically, I can write that all down, and it sort of it works mathematically. But maybe it is the fact that our universe, in some level, is asymmetric. It has a start which is finite in the past, but an infinite future ahead of it, is the reason why we experience the future unfolding. But a lot of that is my personal preference rather than anything really hard and scientific to say, because we don't know how our universe was born. We don't know how it was brought into being. We don't know what wrote the difference between past and future into our universe. But I think the birth of the universe has got something to do with it.
So, in other words, if you were to be able to ask the universe a question and it could respond, if you asked it, why is there an arrow of time? It says, because I had to start somewhere.
Yes, effectively. But of course, if you remove that arrow and you think about the fact that most of physics is time reversible, all this kind of stuff, it doesn't make thinking about time any easier. You just end up with a bigger headache, I think.
Do you think now mathematics has been of immeasurable value in describing the universe? It's how we do it. But do you think that there may eventually be a failure where mathematics does no longer describe the universe? And I use this in the sense of like general relativity breaking down inside the event horizon of a black hole or stuff like that, where it just stops predicting. Do you think that there is something in mathematics that might not be able to describe aspects of the universe?
Well, again, that's a good question that I was having with my students yesterday. Um, I I often wonder about the sciences, right? So we tend to have this picture where physicists talk about, we're doing the fundamental stuff, we're doing the pure stuff, and then chemistry is doing the smelly stuff, and biology is doing the stuff that moves around. But I often wonder if physics is really doing just the simple stuff, the stuff that we can explain with mathematics, and that as you work your way up the scientific tree, that you get to regions where mathematics is less and less of a useful language to describe what we're looking at. And the Astronomer Royal, Martin Rees, I remember him in some of his writing basically pointing out that, a star is much simpler than a bee. So physicists study stars because we can write down equations to study stars, but writing down the equations to describe a bee is a lot harder, right? Because where are you writing your equations? What are you describing there? Are you describing the molecules of the bee, the behavior of the bee, the way the bee flies, etc.? It's a very complicated object. So yeah, I at some level, I and that runs in my mind straight into the question of things like consciousness, right? Is it that we can't describe consciousness because it is it's beyond the realm of mathematics? It's such a complicated thing that we just can't do the sum of the mathematics required to describe something like consciousness. And it might be true. I mean, I know physicists can't describe a bee. So yeah, maybe it's physics. If physics just sticks to the easy stuff, then maybe maths will be fine. But if we do try and push it to the realm of really complicated things, we already know that our standard mathematical tricks don't really work that well anymore.
It's 2 points on this. The first is that the universe can produce something so complex as a bee says that you should probably look for complexity instead of the low-hanging fruit. But also, in its way, that bee is beautiful. Just the complexity of the universe on that scale is beautiful. And to get into, a human and consciousness takes it even further, because it's been said before that consciousness is the universe perceiving itself. But at least, if you don't want to go that far, you can at least say that it's possible to be conscious in the universe, in a universe that didn't have to be that way. Which is another one of those, rare universe theory. The multiverse, we're the only one where everything came together, but there's a bunch of dead universes out there. But let me ask you this now, though. All right, so do you think our understanding, of science is capable of a titanic change? In other words, say we get another Einstein comes along and produces another theory that's way ahead of its time. Do you think that can still happen in science, and that we would gain a greater insight into the universe and sort of let us figure out the differences between quantum mechanics and general relativity, which happened with Einstein? I don't know. I think somebody probably would have figured out special relativity, but general relativity, it took Einstein for that. Do you agree?
Well, I do and I don't at some level. I mean, the problem that I have is that we're now looking back over 100 years, and actually, we do know that there were a bunch of players involved with regards to the discovery of general relativity. I mean, he was I've forgotten who he was now. Oh, this is terrible. I mean, there was another mathematician who Einstein knew, who was working at the time, who was going along a very similar kind of path. I'm not trying to downplay the role that Einstein has had on science. He has had a massive role, but we have to be very careful to think that really ideas that one person has are completely beyond the scope of another human being coming up with those ideas. So the question about will we have another Einstein, I think I think it's bound to happen at some level. We know that science isn't solved. We know that physics isn't solved. We know that we have these huge outstanding problems, and there is scope for somebody to come in and have such a field-changing impact in modern physics. We might not recognize it as such because physics is now much bigger, much more diverse than it was in Einstein's day. And I'm not saying that it wasn't complicated back then, but of course the complications just have grown now. The scope of physics has grown. So there will definitely be revolutions in areas. There will be revolutions in the world of the quantum. There will be revolutions in the world of gravity, and they will happen. I think what has happened, which is more telling, is that we have just become more impatient. We have had, the 20th century saw such a big change, in 100 years that I think we felt like every new mystery of the universe will have to yield its secrets with just, a little bit of a tap with a hammer. But maybe we've settled down into this period where it's going to take a bit of a slog until we get to the next big insight. I said the universe doesn't owe us solutions coming in a 1-year timescale or a 3-year timescale or even a 10-year timescale. It might be decades to centuries, but we don't know. Of course, it could be that somebody wakes up tomorrow morning and just goes, "Oh, hang on," and has a new idea, and that could change everything. But I think there's a lesson learned in science is that scientists are terrible at making predictions for when the next revolution is coming, right? It could just be around the corner, but it could be a century away.
But there then is the wild card of AI. Do you think AI could figure it out for us? In other words, could it say, well, you humans didn't take enough into account, but I can. And it calculates for however long, maybe 10 centuries or less, and it figures it all out. And there it is, a complete view of physics. Do you think that can actually happen? That computers may be better physicists than we are?
At the moment, I'm not seeing evidence of that. In the sense that, being a revolutionary physicist takes imagination. You really do have to look at something from a different perspective to change a field. Now, what I've seen with AI is that at the moment it's very good at collating data and finding relationships, and those relationships might point in a new direction. But the spark of creativity that's needed for science, I've not quite seen it, right? But again, I'm not saying that it's not possible. It's just that I've yet to see anything that I would say, oh, that's told me something new about the universe. But that doesn't mean that it's not possible. And of course, what we are seeing, like in the artistic side of things, AI is starting to, in my humble opinion, is starting to generate art that I can appreciate, and images and video and music that really does start to resonate with me. So it's starting to latch on to what I like as a human. Whether it latches on to the spark of creativity for scientific advance, that's a difficult question. And the thing that I guess frightens, air quotes around frightens, is that if it latches onto a creativity in science that we cannot appreciate, we cannot understand. If it goes beyond, what our monkey brains can really do, then we may never really understand what it's doing. But it's not there yet. So yeah, maybe. I think I'd be very foolish to start making predictions that physicists will never be out of a job. But as of yet, I've not seen evidence that we have to worry too much.
I think what would be funny is if we we created an artificial intelligence, a generalized AI that was able to figure it out, and then it wouldn't tell us. It's like, yeah, oh, I know, I understand the universe, but I'm not going to tell you because you'll hurt yourself.
Well, exactly. It's one of those things. You think of back to Asimov's robot laws, right? And his original robot stories were about how robots basically got themselves tied up, trying to ensure that they didn't damage a human and all this other kind of stuff. But if you've got an AI that realizes that if it gives you some of its wisdom, that there's scope there for us to destroy ourselves, then maybe it wouldn't share it. Yeah, exactly. but who knows, right? Who knows? One of the things that I do love is that there's a long history of AI in science fiction, and there are various songs about machines that run the world for the the sort of benefit of humankind, that we'll never have to work again. And when I was growing up, and still am a big fan of David Bowie, but back in the 70s, he had a song called Savior Machine. And again, it was all about a machine that was running for the benefit of humankind, but then one day gets bored and doesn't know what to do with us. So the ethical questions around AI and what AI will do and how it will interact with us, I think that is a really big question, and I think we are still grappling with that question about how AI is going to be, how we're going to ensure it's going to be beneficial, and how we're going to ensure it doesn't decide that it's going to destroy us anyway.
There's a number of such wonderful scenarios that as soon as you get an advanced enough AI, it concludes that there's no point and turns itself off, so you can't ever develop it.
Yeah, absolutely. Yeah, I've been reading the science fiction of AI, but I've also been looking at some of the ethical stuff around AI, and I do find some of it a little bit frightening. AI in warfare scenarios is pretty scary stuff. So yeah, interesting times ahead, I think.
The key is to end the practice of warfare before you get there.
Yes. Yeah.
And that's I wish that's what the world would focus on before we get there. But what is your two questions? And the first question is this: since we're heading into September, but it's getting close to October, which is spooky season. What is the one aspect of the universe that gives you pause and even spooks you?
Oh, look, I think it's the fact that we know the universe is going to die. Whenever I think about the life of the universe, we forget that we're living in the twilight of the glorious period of the universe. 99% of all the stars that ever are going to exist in the universe have already been born. Right? We are already winding down in terms of the life of the universe. In a time, 100 trillion years from now, the last star is going to go out and the universe is going to be plunged into darkness. And I've given talks on this, what the prospects of life in the future universe is going to look like. And it just gets bleaker and bleaker and bleaker as we go on. Eventually we get out to these immense time scales where matter melts, right? Proton decay and all that kind of stuff. Eventually, black holes evaporate, and we're left with nothing but a cold, empty, lonely universe. And so that often gives me pause for thought, right? That we are living in this tiny window of the universe where it's active and there's stars and there's life, etc. But the future really does look kind of bleak.
And we don't know how it ends. There's multiple ideas, the big rip, and the the heat death of the universe, the proton decay. There's multiple ways, so we don't even know how it's going to end. We just know that it is going to end, and that's what I find spooky about that myself.
Yes, and of course they said there's that slow decline over the infinite future ahead. But as you mentioned, there's things like the ideas like the Big Rip. There's ideas that that the Higgs field could decay and kick off the birth of a new universe, and that would be like instantaneously this universe would cease to exist. It would be like, and that's it. We wouldn't even notice it ending, kind of thing. So yeah, the fact that the universe, of course, it's like everything. We think we're in the universe now, and we think, oh, this is the way it's always been. This is the way that it's always going to be. But really, when you look at it, of course, we were born in a big bang. It was hot, and etc. The key fact about the universe over billions of years is change, and that change is always towards decay and all this kind of thing. So yeah, the universe is always changing, and we are heading for something, but we're not certain what that something is.
Now, Professor, you're also a major horror and sci-fi fan, and so am I. So let's go fictional with it. What story in film or in books spooked you the most?
Oh, story in film. Oh no, that's a good question. I mean, I said I'm a big fan of horror movies, and I tend not to get spooked at them anymore. Oh, I don't have an obvious answer about what spooked me in terms of movies. I can tell you the kind of I'm a big fan of classic horror movies, and of course, they're kind of fun in their style. And I'm also a big fan of the 1980s sort of jump scare kind of movies. So, the Halloweens, etc. But I do like a well-made horror movie. One of my favorites is An American Werewolf in London, which blended horror and comedy together in a an incredible kind of way to come up with a story, which I don't think really has been bettered. So yeah, I don't have an answer to the what spooked me the most, but I do know what I like.
It's interesting. I'm actually a science fiction author, and I have two books out that sort of thing. But the thing is I'm a hard science fiction author, so I'm more in the grain of Arthur C. Clarke than I am anything fantasy. And horror always struck me as a lot of fantasy,
Yeah.
so it was of less interest. But there have been a few that did spook me, and I would say the book version especially, but the movie as well. The Shining. Thoughts?
Oh yes, yes. Of course, the Shining is one of those stories about a descent into madness, really, right? And picking up on the clues that it really is that kind of descent. The human mind always does frighten me, in the sense that I know that inside my head there's a couple of pounds of fatty material that allows me to understand the universe, but at some level it is making up the reality I perceive. That's the part that always bothers me. I know I have eyes, and I know that light is coming into those eyes, and I can see stuff, but that image is all being processed and fed to me somewhere in the back of my head. And I know that my thoughts are related to the chemical balance inside my body and all that kind of thing. So I like to think myself as my consciousness is somehow separate to the universe, but really it's just part of it, and that my thoughts can be manipulated by the chemistry in my body and all that kind of things. It that kind of thing does make me pause sometimes, right? That question of where am I and what am I does bother me.
Ideas, and this is something more in philosophy than anything you could really ever probe or prove. Probably, maybe not. The the simulation hypothesis, that this is
Yes.
all just a simulation. Ideas from the standpoint of physics.
Yeah, well, so this is something I wrote about in one of my books way back in 2016, where we discussed the simulation hypothesis. And so the idea is, of course, is that our universe is nothing really than a computer simulation running in a universe above us, and they've reached that stage where they can do sufficient calculations that all of the stuff around me, none of it is real. Of course, I am just a mathematical calculation, etc. And so the question is how we would ever know. How would we know we were in a simulation, other than a giant game over sign appearing in the sky? And in reality, as a physicist, I don't know if we ever could work it out. Because what we do, of course, is as physicists, we sort of look at the way things behave and we come up with the laws of nature, which are mathematical. But if the creatures above had programmed their simulation using mathematics, all we are doing is uncovering their input equations. So everything we find out about the universe, we just build into what we call physics. And so, yeah, it again, I said there's no obvious way that I think that we could really detect that we are in a simulation. Even if we got down to the scale of realizing that the universe is little bits of information, of course, there are people that think that's what things are at the fundamental scale. And again, that relates back to the simulation hypothesis. And it goes somewhat larger as well, of course. Max Tegmark wrote a book a few years ago now called The Mathematical Universe, in that, you don't even need a simulator above, right? That the universe is just truly mathematics playing out somewhere, and somewhere in the bubble of all mathematics playing out is our universe. Right? Our universe is a place where the mathematics have come together such that we perceive stars and planets and consciousness and people and all this kind of stuff. But none of the reality is real. It's all just mathematics churning its way through the equations. And again, is that really the way it is? I don't know how we would ever know.
That's an amazing thought, that
Yeah,
the universe is a calculation, and that's it.
absolutely. Yeah, and then, but maybe that's the end of the questions, right? Because what if you can't go any deeper? Right? If that's just what it is, then the end of questions, isn't it? I mean, I don't know. I said Max's book goes into this in a bit of detail. Maybe it helps him sleep at night to think that that's where the universe operates, but it's one of those unanswerable things, right? If that's just the way it is, that's the way it is.
Well, everything comes down to that, because you can run yourself in circles, thinking
Absolutely.
about philosophies and,
Yeah.
and things like that, and getting into the metaphysics of things that may or may not be. So you eventually hit that brick wall, but you can try to understand it, which is what science does, is tries to understand it and get as clear of a description and picture as is possible.
Yeah.
Um, Now, to flip that question over, favorite sci-fi story?
Oh, no, favorite. That's probably War of the Worlds. I do like to read War of the Worlds every so often, and just because, So I'm a big fan of H.G. Wells, and I struggle between the choice of War of the Worlds and The Time Machine, and I flip back and forth between the two. But I just think that it's a sign of how far Wells was ahead in his thinking about what exploded into the genre of science fiction today. So those classic books from back then, they're the ones I can read time and time again.
Oops, sorry about that. I had some sort of a hiccup there. Now, the War of the Worlds, the obviously the novel is the ultimate,
Hmm.
but at the same time, I liked both of the movies, the Tom Cruise one and the classic. Was it 1950? I forget.
Yeah.
So, what version of those? What do you like the best, other than the book? Do you like the Tom Cruise version, or do you like the 1950s version?
I think I prefer the 1950s version. I, I, look. I didn't mind the Tom Cruise version, but I don't know. I felt it was a little bit drawn out kind of thing. But yeah, look again. If I had to sit down and watch either one of them, I'd happily spend an afternoon watching the Earth getting attacked by Martians.
Now, in regards to H.G. Wells, the book that gave me pause and actually spooked me more than the War of the Worlds was The World Set Free, where he essentially predicted something like nuclear weapons. Have you ever read that one?
Yes, yes. So, yeah, the world set free and shape of things to come, and those kind of stories. You do sort of have to wonder what kind of information was flowing around just in the public consciousness back then, right? For um, people to realize that there is power beyond chemical weapons, right? Chemical, in the sense of explosives, and that the power of the atom might be the way of the future. So, yeah, those kind of stories where people have laid out the a, a picture which has unfolded at some level to match some of the aspects of the world we live in. It is very interesting that they could think along those lines, but also that with stories again like The Shape of Things to Come, it is that story of knowing what humans are like, and that wars are inevitable and suffering is inevitable and all this kind of thing, which is somewhat depressing that there will be these episodes in human history where we go through that before, like Shape of Things to Come, we have this ultimate utopia at the end, but we have to go through a lot to get there.
You mentioned something that's interesting because you have to know the context of what they were thinking about at the time. But go back a century before that to Mary Shelley and Frankenstein. I don't know that there was anybody thinking about, number one, Antarctic exploration or Arctic exploration, but also the idea of sewing something together and shocking it. Yeah,
Yeah,
I mean, just so far ahead of its time, and you don't see anything after that really for decades.
yeah,
As far as that sort of thinking, and that comes in as my favorite novel, actually, both in horror
yes.
and sci-fi, was Frankenstein, because it's just a work of genius.
It is. But my understanding is that Mary Shelley did know of the experiments, I think it was by Volta, where, by basically applying electricity to frogs' legs, they could get the frog's leg to kick. So I think that was around the same time. So there was a notion, again, what was flowing in the public consciousness? There was a notion that electricity and life were somehow related. But and again, I'm not taking away from her genius. It is a fantastic book. But I think there was some ideas that there was a relationship between electricity and life that were floating around at those times.
Well, come to think of it, there was actually also, I believe it was Benjamin Franklin, that used to entertain dinner guests by electrocuting a turkey. So they
Ah,
they knew something,
yeah.
something. But
Dinner parties were different in those days.
most definitely, and I'm sort of glad
Yeah.
that we have better dinner parties these days. Um, all right, Doctor, we are out of time, and I hope you'll come back sometime soon and talk with us again. And where should everybody look for your books and your YouTube content?
So my books are on Amazon. So I've got 3 books on there at the moment. I'm still trying to get back into writing. So books about cosmology and quantum mechanics and fine tuning, etc. So they're on Amazon. My YouTube channel has sort of slowed down over the last couple of years due to COVID. It hasn't really helped. So I might rebirth it at some point. But I think I'm one of the last people still on Twitter at the moment at cosmic_horizons. I might make the jump to Blue Sky if the ads get any more infuriating. But yeah, that's really my social media appearances right now.